So welcome, good morning, and good on you for making history. Apparently this is the first time that we have ever had one of these Burdekin Dry Tropic Science Forums fully on Zoom. So well done, good on you. It's not even 9 a.m. and we're pioneering. That's fantastic. So I'd just like to acknowledge the traditional owners of the land on which I'm meeting today, which is the Bulgarukuba and Bindal people, and pay my respects to their elders, past, present and emerging, and also my respects to the elders of the lands on which you might be joining us from today. And thanks to you all for your time. We know that everyone's really busy and logging into Zoom for a full day for this. We really appreciate your time, and thanks also for your patience. Now, I will share my screen with you all and go through the agenda. I know most people have this, but we'll just go through the agenda. Hopefully everyone can see that. Can everyone give me a nod that you can see the Word document? Wonderful, thank you. Okay, just because we had a few last minute changes, we'll just quickly go through it. So at the moment we're here in our introduction, and we'll use that Mentimeter tool in a moment just to get a sense of who's here with us on the call today. And then we'll move to Carl Mitchell, who's going to give us an overview of sort of paddock to reef in general, and also the new report card that's come out, which will be really interesting to hear about. Jane Waterhouse is going to talk to us about the marine monitoring program and how that fits into everything. And we will be having breaks for morning tea and lunch as per normal. So just because we're on Zoom doesn't make any difference. We'll still have breaks at those appointed times. Catherine Limaraju will talk us through the catchment loads monitoring program. And then we'll hear from Adam Northey about the paddock to reef farming practice surveys and how that's changed over time. As we know, they've been going for a while. We'll have a lunch break for about 35 minutes. And then Mark Silburn is going to talk to us about the sugarcane modelling, so how it works, how it feeds into everything else. And we'll have some presentation then from some local projects in the lower Burdekin and how they're all fitting into the bigger picture of paddock to reef and what's been happening with those. And then finally, we'll just do a very quick wrap up and close. So again, we'll use that Mentimeter tool just to share our thoughts on paddock to reef at the end of the day. There'll be an opportunity for anyone who would like to make a comment about how they think today went and answer any sort of lingering questions. And now I'll hand over to Rob from NQ Dry Tropics, who'd like to give us just a bit of an introduction and a welcome. Thanks, Rob.
Thanks, Renee. You can hear me clearly?
Yes.
Okay, great. Renee, thank you. That was a fantastic introduction to Zoom. I think a lot of people benefited from that. It's probably one of the best I've ever seen. Welcome everyone to the Burdekin Cane Regional Integrated Science Forum. My name's Rob Hunt. I'm Program Manager for Sustainable Ag at NQ Dry Tropics. And a big thank you to everyone who's joined us today. I do apologise for the change. Obviously with the situation with COVID down south, we had to make a decision yesterday about how we would proceed, and I'm glad we did, and I'm really happy with the attendance regardless, so thank you again. I'd also like to give a shout out to all the presenters. It's a big commitment of time. In a way, I'm sort of thankful that at least we've saved you some travel time, but I do very much thank you for your the preparation you've put into today. I think very briefly, what this forum's about. We've been running the Integrated Science Forum now, or what used to be called the P2R Roadshow, for a number of years, but it's always been somewhat of an exclusive domain for extension staff and a few industry people, but predominantly it's been the scientists talking to the extension staff. And last year we made a very active decision to try and broaden the scope and broaden the audience, and I guess that's part of our scope. We're actually the Department of Environment and Science actually asked us sorry, not the Department of Environment and Science, the Office of Great Barrier Reef asks us to run these forums every year, and I think there's a lot of really good information.
It's lowercase.
Sorry, I thought did someone just mute me, or was I muted the whole time? Not sure what happened. Where did I get to before I was muted?
Sorry, Rob, you got muted just for a couple of seconds there.
Oh, okay, right. So the purpose of today is really to provide a summary of the paddock to reef program to people in attendance, and try and help people to understand what the paddock to reef program is about and how individual on-ground projects fit into that. Quite obviously, the paddock to reef program is a very large program, and it is quite complex, and we're not going to be able to provide you with a really clear understanding of every single component in this time we've got available today. But it's a good introduction and overview, and I'd really encourage people to ask questions. And if you've got further questions following that, email either myself or Jade, and we'd be more than happy to reply. So I think I'll leave it at that. Please, we're going to try and keep this as short as possible. So we obviously, recognizing it's a Zoom session rather than a face-to-face, we have shortened the agenda. We've taken some, unfortunately, we had to take some project presentations out, but I'm confident that those individual projects have got their own opportunities in the future to, you know, to speak to you and present some information about them. So you're not really missing out too much, but I think Zoom's a pretty, you know, sitting in front of a computer for 5 hours is a pretty solid effort. So we'll try and keep this as brief and informative as possible. I hope you enjoy the day. We do have a couple of breaks scheduled in. So yeah, thank you to the speakers again. And yeah, any questions, please just pop your hand up and we'll do our very best to answer them.
All right, well, I will hand over to Carl, who is our first speaker. Carl, I'm looking for you among my, there you are, my gallery of people that I can see on my screen. Are you ready to kick off now, Carl?
Rightio, I'll work out how to share my screen.
Okay,
And
no rush, it's all good.
There. So my name's Carl Mitchell. I work with the Office of the Great Barrier Reef, and a team of us who coordinate the Paddock to Reef Integrated Monitoring, Modelling and Reporting Program and the report card on reef water quality and progress towards targets. I've got a strange echo happening.
Sorry, Carl, we had some technical issues at our end. It should be all good now, sorry.
No worries. Just going to give a brief overview of some of the background behind reef policy and programs and the planning behind that from the perspective of the Queensland and Australian governments. And then I'm going to run into our Paddock to Reef program and give a high level overview of the monitoring, modelling and reporting that we do. And then I'm going to head into giving you a bit of an interactive tour of our interactive report card that was released earlier this year. So that's the plan. So as far as threats to the Great Barrier Reef, we've got 4 key threats that have been identified. They are climate change, which the scientific consensus statement that we delivered in 2017 said was the greatest threat to the Great Barrier Reef. But we also have other impacts that impact much more locally and have impacts on the coastal areas, the inshore areas of the Great Barrier Reef. That's land-based runoff, coastal land use, and direct use such as shipping and tourism and other impacts. Some of the key things for those inshore areas that are related to the land-based runoff are the increase in nutrients in the inshore areas of the Great Barrier Reef, the increase in fine sediments in those inshore areas, the coastal areas, and the increase in pesticides that we've seen. So as a response to that, the Australian and Queensland governments have developed the Reef 2050 long-term sustainability plan. We call it the Reef 2050 plan. It's in a long line of plans going back to about 2002 to try and improve water quality on the Great Barrier Reef. And it looks at all sources of land-based water quality pollution. So we've started now looking at urban and public lands, industry impact, as well as the impact from agriculture. But for us, the agriculture still has the greatest impact, and it's just a size issue. It's the amount of agriculture that's in the catchment that has that scale impact to the inshore areas, whereas the urban, industrial and areas have a much smaller footprint, and therefore their impacts are more localized. The plan incorporates human dimensions, which is a lot of the social science around social, cultural, economic values, what people want to see happen in that area of the inshore Great Barrier Reef. And it sets individual catchment targets for each of the 35 catchments that drain to the inshore Great Barrier Reef. The way that the plan works is it's got an overall outcome for 2050, which is that good water quality sustains the outstanding universal value of a Great Barrier Reef and builds resilience, improves ecosystem health and benefits communities. And then under that, there's a range of objectives of what the plan would like to see the condition of the receiving environments looking like, improved coral condition, improved seagrass, improved land management, improved wetland condition. And then it goes down to the water quality targets, targeted the water quality improvements that would be required to meet those objectives, and underpinning those water quality targeted improvements are the land management changes that would be required to meet the water quality targets. And at the very bottom is the interaction and engagement with communities that's required in order to achieve those land management changes. So it's a bit of a, if we do the things at the bottom, they should lead to the things in the middle, which lead, and as you go up that diagram, the idea is that you're achieving each one of those outcomes. And so the role, we'll just go into the water quality improvement targets specifically for the Burdekin region and its catchments. And they are haven't been set for the Black River because at that stage we didn't have the data to do that, but we are revisiting those targets now, and there will be an updated reef quality improvement plan and updated targets in 2022, the next year. And we're looking at now resetting setting some targets for both the Black and the Ross, which, as you're probably aware, are predominantly urban influenced catchments. And so we're getting some data on what sort of improvements we're likely to need in those catchments. For the Horton Catchment, the main concern was dissolved in organic nitrogen, and looking at a 70% reduction in dissolved in organic nitrogen. Burdekin was a 60%. For the Don, it's more of a sediment story going on in the Don, and we're looking at 30% improvements in fine sediment, as well as particulate nutrients in the Don. So that's a summary of the targets for the Burdekin region in the Reef 2050 Water Quality Improvement Plan, and they're the sorts of things that the Paddock to Reef program, which I oversee, and the Reef Report Card are reporting against. So they're reporting against how well we're achieving those targets. So the Paddock to Reef program, the whole purpose of it, it's an integrated monitoring and modeling and reporting program. It reports progress towards those 2050 targets, as well as that higher level objectives and outcomes that I showed earlier. It's a collaborative partnership. We've got the Australian and Queensland governments, regional groups, researchers, and industries, more than 20 organisations all working together, and quite a few individuals pulling together information across all of the various elements of reef water quality to produce a report on how we're travelling towards those targets. The whole basis of the design is against adaptive management and continuous improvement. So we're always looking to what new scientific methods are available to give us a best understanding of reef water quality. But we lock it into a 5-year improvement cycle. So the way that we work it is that we lock in a method for 5 years so that we can start to see changes over time. If we were continually changing our methods because a new laboratory analytical technique or something became available, then a lot of the changes in the data could be in response to changes in methods. So we lock our methods in for 5 years, and then we do a big change at the end of 5 years, updating the latest science and scientific methods to basically try and present the best possible data and information on how reef water quality is travelling. And we present the report card as an integration of monitoring and modelling data. We use that because the monitoring is giving us a current state of where water quality condition and reef ecosystem health is at. But in order to understand all of the complex interactions from agricultural and urban land management to in-stream water quality to the status of the Great Barrier Reef. We use a bunch of models to try and understand how those relationships work, and using a combination of the monitoring and the modeling gives us the best way of trying to understand that. If we were just using the monitoring, we would be monitoring the things that are impacting the reef at the time where that data sampling is taken, but we won't understand the bigger picture of how various interactions are impacting the reef. So what we're doing is integrating both monitoring and modeling to get the best understanding of how the reef system works. And the program's based on trying to have a really strong interaction between management, the people who are undertaking change to improve water quality on the ground, and the science, so that we can bring those two things into the same space and try and get the best science to inform management so that we can have the best management happening on ground. The way the Paddock to Reef program is set up is that we have a range of monitoring and modeling across all aspects from what's happening in the paddock, how that affects the catchment as well as the state of the catchment, and then what's happening in the marine environment. And we have 10 sort of sub-programs within Paddock to Reef looking at different components of the landscape from paddock to catchment to marine. And the agricultural, on the paddock side of things, we have paddock monitoring and paddock modeling, and we've got we've got Mark Silburn here today to talk about how some of the paddock modeling works, and that's looking at how management practices are being what sort of impact from water quality different types of practices have in the landscape. And then and we do that through paddock monitoring, so we have specific field trials under different types of land practice, and we're looking at the water quality runoff signature from each one of those. And then we use paddock modeling to scale that up for the whole reef to then have a look at what type of impact that might be having in in-stream water quality. And then at the bottom here, we have the stewardship, which Adam Norvey is here today to talk about, and that's looking at what types of practices are happening across the landscape. So in the combination of those two things, what impact practices might have on water quality, as well as what types of practices are being undertaken, through the modeling, we can then have a look at what the impact of current practices might be on water quality. And if there's a change of practice, we can then model that forward and looking what sort of benefits we might see down the chain from that change of practices. Then over in the catchment space, we have catchment monitoring, and Kathy Limaraju is here to talk about our catchment monitoring across the whole of the Great Barrier Reef, and there we're doing actual in-stream water quality sampling to see what the state of water quality is. The catchment modeling then takes the agricultural modeling, paddock modeling, plus the stewardship of who's doing what where, and scales that up to a whole of catchment scale so that we can start to see what the combined improvement from all of the land change might be on water quality going forward. The catchment indicators, we have a range of remote sensing and wetland projects happening to have a look at current riparian extent, wetland condition, wetland extent, and ground cover over time, because they all impact how water quality and how pollutants are generated in stream. And then on the marine side of things, we have the marine monitoring and modeling program looking at condition of seagrass, modeling the water quality outcomes, as well as monitoring water quality, coral monitoring, and there's modeling down the bottom. So that's the program that we have. It's quite a large program. It's running at about $9 million a year, and it covers an enormous area from the Burnett Mary region in the south to the Cape York region in the north, looking at all of the impacts on water quality and how that's being translated into the marine environment. And the purpose of all of that monitoring and modeling is to produce an annual report card, well, a semi-annual report card on the status of the reef and reporting against those targets that I highlighted earlier. So I'm just going to go into a bit of a run through now of that report card. And when I say semi-annual, the report card for 2019 was released in February this year. It was completed in June 2020. It takes us approximately 12 months from the completion of the financial year, which is our main reporting period, to produce the report. That's while we wait for samples to come back from the lab, for data on agricultural management to come in and be processed, and then that all has to go through the modelling process. So it takes us from about June or July of the year following the financial year that we're reporting through to the following June to produce the report card. And then with last year's report card, we had an election and new ministers and a range of things that meant that the report card release was held up until just February this year. So but sometimes can be a bit of a delay in getting that data out. But what we have is our report card on how those targets that we mentioned earlier are tracking as far as water quality improvement and impact on the Great Barrier Reef. So if you go into the Reef 2050 Water Quality Improvement Plan, Reef Water Quality Report Card for 2019, you'll land on this page, which is the overview page, and it gives a bit of a summary of the things that we saw in 2019. We saw quite a large improvement, relatively large improvement across dissolved inorganic nitrogen in our modelling. We saw the largest increases in the wet tropics and in the Burdekin region in best management practice. We saw a decrease in ground cover across a bit large areas, mostly due to drought. And overall, the marine condition is poor. So just some of the things I might point out on this page is a lot of our frequently asked questions. We try to answer in as succinct a form we can at this FAQ page. So if you've got any questions that you haven't quite got the answer to and you can't find, have a look here at our FAQ site and you might find them there. Here's an example: why are best practices in the report card different to those in industry-led best practice? And Adam might talk to this later. But we have a water quality risk framework that we're focused mostly on the impacts of practice on water quality, whereas industry best practice is also looking at a range of other things. And so you can get a bit of an explanation there of how our reporting differs from industry best practice. However, we are actually at the moment undertaking an independent review of the way that our management practice targets and the reporting behind that work. And that's to be completed by the end of this year as an election commitment. So there could potentially be some changes in the way that our management practice reporting occurs. So since we're here for the Burdekin region, we might jump straight into some of the results from the report card for the Burdekin region. And if we go over to this, actually, let's start at the reef and wetland side of things. If we scroll down here to the Burdekin region, we can see that the inshore marine condition for the Burdekin in 2019 scored a D overall, a poor condition, and that's being driven by seagrass water quality and to an extent coral condition as well. And if we wanted to go deeper on that, we can see that within seagrass, we're not seeing a lot of reproductive effort. We're not seeing a lot of reproductive structures on the seagrass themselves. We've seen a decline in seagrass from the previous report card and a slight improvement in coral from the previous report card, with and these little arrows on each one of these indicators is saying where it's what its trend is relative to the previous report card. So we've seen a decrease in water quality as well. And then there's a bit of a text description of what's going on there and what we're seeing in the data from the marine monitoring in the Burdekin region. And Jane might give us a bit of an update of what the science is saying for marine condition in the Vatican region. So moving on, we go over to the catchment side of things and have a look at the Burdekin.
Carl, if I could just interrupt you for a moment, sorry. If we could look to wrap up maybe in about 5 minutes or so, just because I know you've got at least one question, so thank you.
I can do even quicker than that if we want. So I'm assuming that a lot of people have access to this or know about the report card and have had a look at it. If not, I'm happy to go into much more detail with you, but in interest of providing a lot more time for questions, I'll just highlight some of the things at a regional scale and then we can go into questions. So we've seen a 4.5% reduction in it from our modelling for dissolved inorganic nitrogen for the Burdekin region, which is the best improvement we've seen to date in our reporting, but still seeing quite low changes to sediment. Across catchment management, ground cover seems to be the biggest, the least amount of change. We've seen some ground cover condition has been the worst, and we said that was from the drought. And then from a land management point of view, we haven't seen a lot of changes of those low water quality risk practices in sugarcane in that 2018-19 financial year. So Renee, I might open up to questions from there, and we'll see how we go.
Okay, wonderful. Thank you, Carl. Appreciate that presentation. Phil, you had a question for Carl, I believe. Did you want to unmute yourself and ask your question?
Yeah, I believe I'm unmuted. Can you hear me?
Yes, thank you.
Rightio. So at the very start of the presentation, there's something that struck me, and that's why I want to question.
Yep.
So you said there was an increase in DIN and pesticides. Increase from when? Well, where are you measuring from? Where's the starting point? So I farmed in the Burdekin all my life. My grandfather started here, and the practices that used to happen have changed so much over the last, well, have to be 70 years we've been farming. Why didn't the reef die in the 70s, 60s and 70s? I mean, we were just pouring pure nitrogen, pure urea on the paddocks, and then a bit more just to be sure, not just us, but everyone here. Pesticides, well, we were using pesticides that, got a half-life of plutonium, and no one uses them anymore because no one wants to die.
Yep.
So my question basically is, how far back do you go? How far back do you go to actually recognise the real change that has happened, particularly in the Burdekin? I can only talk about the Burdekin, but the whole sugar industry is in the same boat, and there's no recognition of that. So I find it impossible when you said that there's an increase in DIN and pesticides, and that was the starting point.
So fortunately, I have Jane in the next presentation who's going to tell us all about that. So she's going to give a full background of where that information has come from and what the findings of our scientific consensus statement is. The reporting that I'm presenting here is the improvements that we've seen from 2009, but the increases in pollutants prior to that is the subject of the Reef scientific consensus statement, and that's our next presentation.
Radio.
Great. All right. Thank you, Phil. Thank you, Carl. Any more questions for Carl? All right. I can't hear anyone, and I can't see anything in the chat. Again, if you're a bit of a slow typer and you're not quite there yet, that's okay. Any questions can go in the chat box for our speakers to answer out of session. But again, just a moment if anyone's got any questions.
And if you've got any more questions of me, you could probably, through Jade and Renee, reach out and I'll do my best to answer them.
Wonderful. Thank you, Carl. All right. Now, just while everyone's doing that, I'd just like to invite Jane to get set up. How are you going, Jane?
Yep, good morning.
Just
Right,
me.
right. You're going to have to keep me on time, Renee, because I'm
Right.
trying to present a whole bunch of slides from lots of people. So good morning, I'm Jane Waterhouse from Trotwater at James Cook University, and I'm going to give a overview of the marine monitoring program. I was going to skip the intro sort of stuff around background and the consensus statement, but seems Carl referred to it. I popped it back. So Renee, just keep me informed when I'm getting close.
Will do. Thank you.
So just to touch on it, Carl covered it, but really just emphasising the value of the Great Barrier Reef. It's a highly interconnected system with the adjacent catchments. It's massive. It's the size of the UK and Ireland combined. It's got an enormously long coastline. It's highly diverse and it's valuable in terms of its ecological and economic values. It's, as I said, it's highly connected, and we've had large modification of those catchment areas since, I guess, European settlement and with the development of agriculture, but clearing for grazing as well. And that's led to changes in the amount of material that's discharged to the Great Barrier Reef, not only because of those land uses themselves, but also the modification of some of those coastal systems, which naturally would provide a bit of a trapping and processing mechanism. Importantly, every region's different. So if you just have a look at this map to the right, you can see the reefs are located in this beige colour, seagrass in green. As you move from north to south, the reef sort of moves further offshore, which makes a difference to the influence of water quality on those areas, which is typically constrained to the inshore reefs. Up here, though, it extends to the mid-shelf. And as we've moved further south, I guess we see less implication of water quality on these outer reefs here. Seagrass is largely inshore, and they're hard to see. This is this bright green, it's the surveyed, hard to see at this scale. And then deep water seagrass is these darker green. So just, yeah, highlighting there, every region's different, and that then makes a difference to the implications of water quality. As Carl alluded to, well, overall, the condition of the Great Barrier Reef is reported as being very poor. So that was the 2019 Outlook report. It's been through a lot in recent years. It's had bleaching, it's had cyclones, flood events, Crownathorn Starfish outbreaks, and then I guess almost in the background and ongoing is that land-based runoff. So that in 2017, that was the last consensus statement that came out. It was very similar to the previous statement, in fact, for that first point. So key Great Barrier Reef ecosystems continue to be in poor condition due to catchment development, extreme weather events and climate change impacts. And then the second part, which was a really important addition for that iteration of the consensus statement. So they're done every 5 years to support the Reef Water Quality Improvement Plan updates. So it was recognising then that what we were doing, even though we were making great changes in the catchment, is probably not going to be enough to meet the water quality targets. And governments at that point started to recognise that we really needed to accelerate the change in how that's done, which has to be accompanied by changes to governance, better coordination, better program design, and then improvements in our delivery and evaluation system so that we can say what we're doing well, what we need to improve, and how it's working in terms of working with the landholders and other stakeholders, including urban and other areas that might be influencing the system. So which aspects of water quality? So every 5 years, to support the consensus statement, we do a review of the relative risk of pollutants to the Great Barrier Reef ecosystems. So for nutrients, it's, I guess, largely in those inshore areas, but in the around the wet tropics, the influences extend to the mid-shelf and sometimes offshore coral reefs, and they are linked to the promotion or initiation of Crownathorn Starfish population outbreaks. So basically the larvae it tends to have better survival with more nutrients. It also promotes macroalgal growth, and also when you've got other stresses like bleaching, it makes the corals more susceptible to damage, for example. With fine sediments, the story is really there about reduced light available to seagrass and ecosystems at mostly on the bottom, so inshore coral reefs, and that tends to be largely in the inshore areas. And for pesticides, we have a better understanding now about their relative risk. It's largely constrained to those freshwater, inshore and coastal habitats. So where they're closest to, where they're discharged closest to, is the ecosystems at greatest risk to those. So working with the information about catchment loads and delivery, and then that marine risk, in 2017, priority areas were defined for improving Great Barrier Reef catchment management. The Burdekin features quite highly in terms of those priorities. So for sediment particulate nutrients, it's the highest, almost by twice as much as any other basin. So that's the Burdekin Basin itself. For the dissolved inorganic nitrogen, the Horton ranks quite highly, and that's that lower Burdekin area, which we're interested in talking about today. And then for pesticides, the highest priorities are really around Sandy Creek and Mackay Sunday, the Pioneer, and to a lesser extent, but important, Barada Creek, and then Tully and O'Connell. So that enables us to target management, and as Carl said, that's been rolled out through the Reef Water Quality Improvement Plan. How do we know? So all this evidence has been supported by a wide range of published scientific research, monitoring and modelling since the 1990s. So when I look back at what the consensus statement said at the very beginning of all of this in early 2000s and what we're seeing now, some of the evidence is very foundational. It hasn't changed. We've got high confidence in it. Some things we're not so confident in, and continuing to improve our knowledge of that. We also get input from practitioners and local experience about what they're seeing on the reef, and international collaboration. So we're not the only reef system in the world that's influenced by land-based impacts. So there's opportunities there for learnings and linking to those research outcomes as well. So in all of this, look, I've written monitoring and monitoring. I meant monitoring and modelling have an important role in assessing and informing the priorities for the Great Barrier Reef, which is how as Carl said, the Paddock to Reef program fits in. So for the marine monitoring program, so we're just looking at Carl's diagram again. So I'm focusing on this part of the story. It's really about assessing the condition and trends in ecosystem health and resilience indicators for coral and seagrass we've been doing that since 2005. So we're looking at annual results, but particularly long-term trends. When you're looking at water quality, imagine it changes quite rapidly in annual conditions depending on how much rain and discharge we get. And also though looking at condition and trend of seagrass and corals annually, which can change more rapidly depending on the types of influences or disturbances in the system. So for an overview of the marine monitoring program, I'm just going to show a little video that's just been put out by the Great Barrier Reef Marine Park Authority. So I'll give this a go. Let me know if you can hear it okay. Just goes for a couple of minutes. Oh, that's a shame. No luck?
No, I can't see it playing. Can anyone else see it playing? No, no. Okay, I'm seeing some headshot.
What would happen if I might jump out of my screen because I really want to show it and try to display here. Here we go.
Okay, thank you.
No, it said it can't play. Oh, what a shame. It worked.
Will you have to reenact it, Jane?
Yeah.
On screen for us.
Yeah, no, that's not a good idea.
Okay.
I'll see if I can make it work afterwards. Okay. anyway, it was a nice little overview. I can send the link to people. So I'm going to give an overview of what we're seeing in the marine system in the Burdekin region. So first of all, I'll cover some of the pressures that we've seen now over the last couple of years. So the report card that just came out was 2018-19, but we've got results from 19-20 that I'm going to show as well. So the pressures are relative to that. So over here, this is the period that we're looking at in 2018 to 20. Of course, we had Cyclone Owen and Penny go through the Barrier Reef in 2018, and then we had the significant floods in the early February of 2019 in the Burdekin region in particular. You can see though the patterns of cyclones and in their intensity has changed over time. And this period between 2014 and 17, we had some real doozies with Debbie in particular, and then even here we had Yassi in that time around 2011 where we had some of the greatest flood inputs that the reef's ever seen. In terms of the river discharge, so this is an important pressure for reef ecosystems, and I've highlighted here, this is all regions. This is the Burdekin region. So what the colours represent, we look at a long-term median of river discharge for the region. Anything in red is more than 3 times that long-term median. Orange is 2 to 3 times, yellow 1.5 to 2, and then less than that is 1.5 times. So we can see that in 2019, that was that big flood event that we had in the Burdekin here. And then the wet season that we've just, 19-20 was well below average. So we had a pretty dry year in 2019 and 20, and that's actually the case across the whole Great Barrier Reef. But you can see here the high variability across the regions, and that the Burdekin is in fact one of the greatest discharge areas across the whole Great Barrier Reef. Water temperature is also a really important driver for marine conditions. So these maps show degree heating weeks. So that's the number of weeks that it's above a long-term average as well. So here we can see, I'll start over here, 2016, there was significant bleaching. It was largely constrained to the northern Great Barrier Reef. 2017, it moved, unfortunately, focused in the central Great Barrier Reef. We had a couple of years of reprieve, and then 2020, we saw bleaching across the whole Great Barrier Reef, including those southern areas that had escaped these temperature anomalies in the previous events. So I'll talk a little bit now about what water quality monitoring is done. So Renee Gruber at AIMS and I lead the Inshore water quality monitoring program. Just what do we monitor and what, where do we monitor first of all? So these are all the sites across the whole Great Barrier Reef. We look mostly in the open coastal water bodies. So that's those areas relatively close to shore. I mean, we call it inshore. There's 58 stations along the whole Great Barrier Reef from Cape York down to Mackay Whitsunday and Fitzroy been reinstated. Most sites get visited 3 to 12 times a year. We've got some additional event-based site sampling in the blue here that we do just in events. And then we've got some continuous loggers of turbidity and chlorophyll at 16 stations along the Great Barrier Reef. So for the Burdekin region, here's our water quality monitoring sites. So they span from down near the Burdekin River mouth out to the Ongala, around these coastal areas to Magnetic Island and basically the Palm Island group. So that's where we visit regularly. What do we measure? So physical variables, just those environmental conditions, so temperature, salinity, water quality, and stratification. So what are differences between the surface and the bottom? It tells us about the local conditions, and then the movement of and where the freshwater influence is in coastal waters, particularly in events. For the biological variables, we look at chlorophyll and total suspended solids. So chlorophyll is actually a pigment found in phytoplankton. It tells us about productivity. Total suspended solids tell us more about light availability in coastal waters. And here's, I mean, this is a pretty bad example. That's a really turbid environment, but that's the kind of thing that we're able to measure the difference in composition and light. So the chemical variable.
Just to interrupt you, Jane, sorry, just a heads up, you're about halfway through.
Okay, thanks. The chemical variables, so we've got dissolved nutrients, particulate nitrogen and phosphorus, carbon, colour, dissolved organic matter. So they tell us a bit more detail about what nutrients are in the water. And then how do we use the data? So as I said, it's really about the long-term trends that we're interested in for the water quality story. Here's an example of a complicated graph, but what it's showing there is they detrend the data. So as I said, we try and take out the influence of wind and other factors that would change at a higher variable throughout each year. And they determine this trend. So this is an example of total suspended solids. Here's the scale of milligrams per litre. Note that it's log from the beginning of the program to where we are now. And that's actually showing that that concentration has decreased over time. So that's an important outcome here. Also highlight that in 2015, we changed the design. So each one of these black dots represents the sampling location. So you can see we're doing a lot more sampling now than we used to. So for the results for Burdekin water quality, meeting the water quality guidelines for chlorophyll and total suspended solids and exceeding the guidelines for a number of nutrient parameters as well as Secchi depth. Trends over time, so decreasing, basically improving. So phosphate, chlorophyll, total suspended solids. So they're all linked to runoff, stable as some of the nutrient variables and Secchi depth, and then increasing, as in getting worse, is particulate nitrogen. And we can see that trend's quite significant. And I will say we don't fully understand that at this time, although it's probably linked to some of the soil erosion and the nutrients being transported with that. So the trends in the long term, so these show a water quality index. So for the Burdekin, we can see it's been moderate over the last few years. We saw this slight decline, but it didn't actually change the scoring when we had the 2019 flood events. And you can see it's different in every region. Won't go into that other than to say when you look at some of those areas, the Burdekin's not looking too bad. So remote sensing, I wanted to just touch on this because it's a really useful tool that gives us a large coverage of the reef. So what do we measure and why? We combine satellite imagery to look at where the river plumes go. We can characterise what's in them. We can identify where they're likely to exceed the guidelines, and from that we can look at the exposure of reefs and seagrass to different water quality parameters. So it really focuses in the wet season only. And tells us more about composition over different time and spatial scales. This is one of my favourite parts of the remote sense link, just the satellite images. So you can see some amazing examples here of the Burdekin in flood. So these large events of 2007, this absolutely doozy in 2011. You can see here the fine sediment material coming out. When you see these greenish waters, that's typically when we've got algal blooms in the marine environment. You can see here we've also got some coloration around the mid and outer shelf reef, so that'll mean that there's probably been nutrients out there for a little while. 2017 we've got a similar one, and you can see this really dark greenish water, which is an indicator of nutrients. And here was the 2018 floods where this water hung around for a few weeks, so you can imagine the light on these ecosystems would be quite reduced. I might skip this detail other than just to say we can use the colour of the water to characterise it. Caroline Pettis in our team looks at that. It identifies gradients from as you're closer to the coast, as you move further away, and that's how we can use remote sensing as a widespread tool for water quality itself. We generate weekly outputs. It tries to link what we're seeing in the marine environment to wind, river discharge, and then when we've actually got water quality concentration. So, you know, that's something that I could talk about on each one of those weeks, but it's really useful to see that on a weekly scale. So for an example here, where we actually had some discharge, you can see the influence in that plume distribution from the Burdekin River when there was some flow. We also do river dispersal, which is using the ARES model to model out the end of catchment loads into the marine environment. You can see this is the 1920 map for dissolved inorganic nitrogen. It was very constrained. It was a very dry year, so you don't see much material getting out there. What this shows is what we model now. This is what we estimate was from pre-development. So this is what we call our anthropogenic loading map, and that's the difference. And then you can see that, I guess, it links back to those targets that Carl was talking about, which are also based on anthropogenic loading. We can go back over many years and compare what happens over time and with these big events, how that makes a difference. So the coral monitoring, how long have I got, Renee?
You've got about 15 minutes, Jane, before we go to questions.
Yeah, okay. So Angus Thompson has given me these slides, and there's a couple of videos. I'm afraid they might not work either, but we'll give it a go. So the coral monitoring sites, so here across the whole Great Barrier Reef, they actually do pick up the Fitzroy. Here are the region sites within the Burdekin region. So from the Palms in the north down to Magnetic Island. Just in terms of the drivers across the whole Great Barrier Reef. So when we think about coral cover, which is a good indicator of coral condition, or one of the indicators, I should say, we can see that there's many influences on there on coral cover. And this is the whole Great Barrier Reef, not just the Burdekin, but I just wanted to highlight it because obviously I showed that map of the bleaching. It had a significant influence on coral cover in 2020, whereas say somewhere like this, which is 2017, we had Cyclone Debbie, which hung off the Whitsundays for a long time. And so storm influence was one of the greatest factors on that. So this is partly modelled, but is based on that monitoring data and linking different disturbances to coral response. So that's also presented in Angus's report for at a smaller scale. Bleaching response, I wanted to show this because this just highlights that fact I made for the Burdekin. So this is the % of hard coral bleached. You can see that Burdekin escaped fairly lightly in those 2016 event, not so well in 2017, and was fairly hard hit in 2020. Let's see if this
We started out at northeast reef of Orpheus Island, and the corals were in really good condition there. They've recovered really well from Cyclone Yasi, where there was almost.
So Angus was just describing to us then, this is their Orpheus Island site. So they did some surveys in April 2020. You can see it's in pretty good condition. This was at the beginning of their survey period. And he was just saying it's had pretty good recovery since Cyclone Yasi. If we go to the next, Havana Island, which is just a little bit further closer to the coast, you can see the significant difference.
Probably the worst was at Havana, where there was some mortality happening. Almost all the coral was bleached, but it hadn't died, so we expect a lot of that to recover. Just finishing off today at Jeffrey Bay. Again, there's quite a lot of bleaching. Corals are still quite white, but again, there's not a lot of obvious mortality from the event, so a lot.
So they just highlight to us the difference that we see. So when we talk about the Great Barrier Reef being in very poor condition, it's obviously very patchy and variable between sites. And here was just an example of how that varies just within the Burdekin region. But they are sort of seeing some good recovery from that bleaching as well at some of the locations. So coral index, you see the coral score in the report card each year. There's a number of factors that they use to come up with that metric that are important for coral condition. So the coral cover, the amount of juvenile corals, so the babies, if they're reproducing, they're generally healthy, the amount of macroalgae, which is not great, the coral cover increase, which is always a positive outcome, and then community composition, which is a really important indicator of disturbance. So the scores generally range from, very good to very poor for every ecosystem. So these is a bit more detail on how they come up with that one. When we look at the change, here's in the actual metric scores. This is moderate and then this is poor, the orange. And we can see that in the Burdekin region, it's been moderate for a few years, and they're each of those factors I showed you before that make up that score. So in terms of the summary of the inshore reef condition currently in the region, or this is across the GBR but relevant here, cyclones continue to be the primary cause of coral cover loss on inshore reefs. Those inshore reefs have been pretty lucky, if you could say that, and they've escaped severe loss of coral during the bleaching events, as Angus showed in the video. COTS on inshore reefs are very much limited to the wet tropics. And then we've seen some changes in resilience. So during, we see those reefs largely during those declines during the periods of high catchment input and in locations that are close to coasts and rivers. So water quality does provide an extra stress at times of other disturbance. So seagrass, this is all my last few slides. So Len McKenzie provided this for me. So seagrass monitoring is undertaken along the whole Great Barrier Reef coast. They look at abundance, reproductive effort and tissue nutrient status. They're all their main condition indicators. In the Burdekin region, hard to see at this scale, but there's 4 locations. There's 3 coastal intertidal meadows at Shelley and Bushland Beach and Girona in Bowling Green Bay, and then a reef intertidal and shallow subtidal site at Magnetic Island. Seagrasses are very important in the region and the Great Barrier Reef as a whole. So they're provide important habitat for fisheries as well as an important food source for dugong and turtle. They're also really important for migratory seabirds. Here's the examples of those sites I mentioned. There's 12 species in the region, but unfortunately there's also a recorded history of loss in this area. But it does recover and come back and then disappear again, depending on disturbances. The coastal and sort of those inshore ones are well represented, particularly in the Cleveland Bay and Palm Island group. There's no estuarine systems around here, and deep water seagrass are a little bit further offshore. For the results for the region, the abundance is really has fluctuated over time. You can see across those sites, reproductive efforts in a pretty poor state, which means that they're not reproducing is not a good sign for overall health. Leaf tissue nutrients, they're an indicator of water quality, indicating that to be moderate to poor, and then overall condition for the region has been poor for the last couple of years. That'll be largely linked partly to that large event of in 2019. So we had reduced light availability for a long time in the Burdekin region. For the overall then, that's what I just mentioned. So those large events, it declined from moderate to poor so the last 2 years have been poor, and prior to that it was moderate. So it does recover over time. You can see that variability in recovery and then decline again. These were the 2011 events. So it took a while to recover, and then it sort of declined again with some more recent flooding. So that's the marine monitoring program for the Burdekin region. This is my last couple of slides. So in summary, combined discharge and loads calculated for 2019 were big, but they weren't as big as some of the previous events, but still well above the long-term median. The 2019 was relatively dry, so it was quite different to that. We actually didn't do any event monitoring last wet season. Then the extent of influence was relatively constrained as a result of that. So for the report card indexes, just to recap, water quality remains moderate overall. Over the last 5 years, it tends to be stable or improving for most parameters, except for particulate nitrogen, which is positive for the other parameters anyway. And coral condition remains poor, but we do see some of that recovery occurring. And then seagrass condition remains poor, and I think that'll continue to fluctuate over time. If you're interested in finding out more, and it would be nice to have shown you that video, but never mind. If you go to the Gabrumpa website, they've got that little video there and it gives an overview of the program. And then the eAtlas has a page for each of the program components, just describing a little bit more about the methods and where we go and what we do. And just to finish off with our acknowledgements, so the partners in the program, it's led by the Great Barrier Reef Marine Park Authority, funded by the Australian Government, Australian Institute of Marine Science, us at Trotwater, and then the Cape York Water Monitoring Partnership undertake the Cape York Monitoring. We get our loads data from Ryan at DES, and it's also modelled, and then we get that satellite imagery data from the Bureau of Meteorology and also NASA as well. So yeah, thank you.
Okay, thank you, Jane. I'd like to open it up for questions now. If anyone has any questions or comments. Yes, I thought I saw a hand go up there, Phil. Did you have a question?
Well, if no one's going to ask one, I will. Can you hear me?
Yes.
Yeah. So once again, it's basically the same question I asked before. So I've lived here all my life, and you talk about flood events, and I certainly wasn't around in the 40s, but my father was, and we had a massive flood then. I've been through, just myself, 5 floods before 2020, and at least two of them were massive in 72 and in 1990 from memory, something like that. So what I'm saying is floods have always happened here.
Yeah.
And like I said before, back in the 70s and 60s, the amount of fertilizers and pesticides and stuff and herbicides that we used, we would never dream of using today. And where is the recognition of the change from then till now? And also the point I keep trying to make is back in the 60s and 70s, with what must have been going on to the reef is still in reasonably good condition. And certainly we've cut a lot of pesticides and nitrogen from those days to now. So it's a bit, I think the snapshot is too short.
Yeah.
And for me, who's someone who's lived here all my life and keep hearing, and I guess the media doesn't really help, because when you talk to scientists, you get a different view from the media in the cities that the reef is dying and going to die in 5 years' time, which I don't believe is the case, and I don't believe you're saying that either.
No.
But that's the message that we keep hearing. And this affects us. Your report card and everything that we hear on the media affects us directly as growers because of government regulation, which is really just tying our hands behind our back and will drive us to becoming unprofitable, and the sugar industry will disappear. Maybe some people want that, but it's not something I want to happen.
So I'll have a go at answering how do we know there's been changes over time. So nutrients is a little bit harder to show over time, but we have got a lot of good coral core data which looks at sediment changes over time. And from that, we can sort of infer that the catchment has been changed in terms of the amount of material that comes off and the amount of water, because the hydrology's changed when you've got those changed drainage patterns in the coastal environment. For nutrients specifically, we do have a long-term data set, but it would only go back to the 1980s. And so you're right there, it's really challenging to say, well, how can you say that water quality has declined, and it's, how different is it to what we saw with catchment development around the 60s and 70s? And we do have a long-term data set from the 80s of chlorophyll showing that decline over time. I probably want to emphasize though, and honestly, pesticides weren't measured back then, so we wouldn't actually have that answer. What I want to emphasise though is that before we're seeing an increase in the cumulative impact. So it's not just water quality. We've got bleaching, we've got other Crownathorns outbreaks, we've got more cyclones, as in terms of the larger cyclones, more intense events. And so you put all that together and water quality then plays an important role. And I guess that's why we focus on it, because it's something that we can attempt to manage at a local scale. Stuff like climate change is quite daunting in terms of what you can actually do at a small scale to influence how often the reef bleaches. If it's bleached though, and we've got less material coming off the catchment, the chance of it actually recovering is better. And so that's one of the main drivers to improving water quality in the catchment, is that when we've got all these other disturbances, which are happening a lot more often now than they were, water quality is actually one of the things that we can do to help it recover by not having it in a poor state. Crownathorn starfish I mentioned. If we see influence from the Burdekin region into that northern Great Barrier Reef, where we think the initiation occurs during the really big events, but not on a very regular basis. So that'd be say 2011. And I could have showed a nice little animation actually showing some modelling of where that water goes and how far north it can actually travel, up to 500 kilometres. We're seeing that water from the lower Burdekin discharging into those northern areas. But you're right, we don't have long-term data about pesticides, and it's harder to trace back to the 50s in terms of marine condition. We can look at discharge and we can have a look at catchment modification. And Stephen Lewis actually has put out a fantastic paper finally about changes in land use and how that's affected the amount of material coming off the catchment. And he's gone right back to the 1930s with some of those data sets. So I can ask Steve to maybe circulate that to the group, because I find it really interesting. We probably have to turn it into something that people are going to want to read, because it's a very long paper at the moment, and maybe we could just focus it on the Burdekin. But yeah, I'll have a talk to him about that. But Phil, I'm happy to talk to you, follow up separately too, with looking at some of the more detailed data sets that we've got for the region.
It's just that it's very frustrating because, and I'm not saying that we don't, everyone who lives on planet Earth affects the environment. I understand that, so I'm not saying we have no effect, but I'm a bit concerned about the balance, and I'm also concerned about the political implications, and which your work as a group does influence, and I think it's influencing us as growers in a pretty harsh way, the political influence. I'm not saying that it's you're driving that. All I'm saying is, once it gets into the political sphere, it becomes a nightmare. That's my frustration with it all.
Yeah, no, I understand that. And it's pretty difficult with our political cycles being so short as well, because even if we get the opportunity to get some good funding and on-ground actions going, it sort of changes in a relatively short time before you get into it.
Phil, can I try and tackle
complex issue? Yeah.
Phil, can I try and tackle your question from a point of how far we've got to go, sort of what sort of improvements are needed and why? So instead of saying what's happened from historical numbers, the modelling that we did to set those targets was based on what the requirements of the seagrass and the inshore communities need to maintain basically healthy seagrass in, sorry, Jane, I keep forgetting the name of the bays around Townsville that cop sediment.
Cleveland and Bowling Green Bay, yeah.
So we kind of worked backwards from what water quality is required to maintain those seagrass and how much of a reduction from what we're seeing today or from when we did those targets in 2017 to maintain those healthy seagrasses. And that's where the 60% sort of came from. So we've got a degree of confidence that we still need further improvements if we're going to see those healthy inshore ecosystems continue and improve. So that's sort of where we're coming from the need to see continued improvement in water quality?
Yeah, sorry, I should have explained that. So we have a fair idea of what is the reef needs to in terms of nutrient and suspended sediment concentrations before it starts to decline in condition. And that's how those targets have been set. It's like, all right, what do we need to reduce the inputs by so that we can achieve those concentrations on a regular basis? So that's to maintain health, not necessarily improve or recover. So yeah, sorry, Carl, I should have, thanks for picking up on that. And the same with the pesticides. So actually the focus has largely been on end of catchment concentrations of pesticides now. So where our assumption is this doesn't exceed at end of catchment, we're not seeing it in the reef system at levels that are likely to cause ecological harm. So the focus there is end of system.
Okay, thanks guys for that discussion. I can see a couple more people with their hand up. I can see Michael and I can see Rob. So could I invite Michael? And I can see Dave as well has got his hand up as well. So if I could ask for Michael and then Rob and then Dave to share with us their comments.
Thanks, Renee. Jane, thanks very much for that presentation. And thank you for recognising that every region is different. And that's one of the challenges for everyone in different regions. And not only within those regions, there are different things occurring in each region. So in terms of a district and sub-district level. So that's one of the challenges for us is to respond to these rules and laws, noting that there's so much difference and diversity happening. I did want to direct my question to, firstly, is water quality monitoring occurring in the mid-reef and outer reefs? I was looking at your map in terms of where those water monitoring or water quality monitoring was occurring. And I just wondered to what extent is happening in the middle and outer reefs. And I guess, secondly, in terms of everyone's focusing on the targets, we know some of those targets were amended a couple of years ago and increased to make them higher. How often are the targets reviewed? And at what point in time, certainly from my point of view, will everyone realise that those targets are both unrealistic and unachievable or unattainable?
Okay, so the first question, the AIMS long-term monitoring program looks at the mid-shelf and now offshore, and that's been going for a much longer time frame. So the marine monitoring program largely focuses on inshore areas. I can send that link as well to the AIMS data sets, and that typically shows, you know, I showed that map and the regions and the distance from the coast. So the wet tropics, we tend to get some of those elevated concentrations in the mid-shelf, and sometimes the plumes extend even further than that. As you come down towards the Burdekin, we rarely see water quality discharge extending out to the mid and outer shelf reefs. And having said that, in 2019 with that big event, the water went straight off the coast out to Old Reef, which was particularly unusual. It depends on the wind for the particular event. It's usually driven north. In relation to the and the remote sensing helps us understand what's happening on the mid and the outer shelf reefs as well. And that's across the whole GBR, which is great in areas where we don't have a lot of monitoring, like the Burnett, Mary and Fitzroy regions. The targets question, can you, I forget it because I was getting consumed with that one. What was the particularly about, why did it increase?
Well, how often are they
every 5 years, yep. So they're reviewed in line with the update of the Reef Water Quality Improvement Plan, Reef 2050 Water Quality Improvement Plan. So there will be a minor review being done next year, but that's largely for this year, next year, the areas where we had the greatest uncertainty, which actually in this region does include the Ross catchment. I don't think that we'll see any significant changes to many of the other locations. The change in them was because we, as Carl just explained before, we took an approach at looking at what we're calling ecologically relevant targets. So they changed from an approach where we were looking at a proportional reduction to something that linked it specifically to the marine ecosystem, which is quite an improvement. So it said, well, in order to meet those guideline values for chlorophyll and for suspended sediment around nutrients and light, how much do we think we need to reduce that into catchment load? And that's based on our understanding of what happens to those materials when they get into the marine environment, and how they're transported and processed. So that's the reason for that change. In most of the basin targets changed a little bit, but I think I've got more confidence that those targets are actually linked to an ecological outcome with that latest iteration. In terms of achievability, I think that's a real challenging question. We can do some modelling. I don't know if anybody will talk about some of that scenario work, Carl, where we can have a look at how far improvements in management practices will get us, but also other things that need to be taken into account, like improving system function. There's some wetland work going on in the lower Burdekin and other regions as well, where we're recognising that those systems used to play a really important role in trapping. It's quite different in different regions, as you recognise too, like the lower Burdekin where you've got irrigation systems is completely different to somewhere in the wet tropics where you've got massive rainfall events and, in my view, very little trapping. So, yeah, there's other things that it's not just about practices, it's about the whole of system approach as well. So, Carl, do you want to add to that?
Yeah, so we have done some scenario modelling looking at how close we get to the targets under different levels of adoption of the water quality practices that we've described in the Paddock to Reef program. And in quite a few cases, those targets can be met with a combination of the low and the very low risk practices. So what used to be called A and B class practices. In most areas get us to those targets or very close to those targets. The exception to that was in the Mackay-Whitsunday region. But within the Burdekin, we got pretty close, the modelling got pretty close to achieving those targets under high levels of adoption of low and very low, of low and moderate risk practices. So Adam might talk about some of those practices in his presentation. That report's being finalised and it should be out late April, we're thinking.
Okay.
But the main thing, I suppose, the main point is those 90% adoption targets, they're the one for land management, they're the ones that are under review for the next, until the end of the year. So we could see some very different targets on land management targets. That's all an independent process, so we're not really sure what that's going to look like when that comes out.
Thanks, Carl, and thanks, Jane, for answering that question, and for Michael for asking. Now, Rob, did you have a question that you wanted to contribute?
Not so much a question as a response, I suppose, to Phil.
Sorry, Rob, could you speak up a little bit, please? Sorry.
Sorry, I was just going to response somewhat to Phil. I guess we shouldn't lose sight of the fact that the lower Burdekin actually performed pretty well in that report card. You know, the DIN result, for instance, is actually, you know, a 4.5 to 5% improvement in a reduction in the DIN load is actually a pretty outstanding result across the Great Barrier Reef catchment as a whole. So I guess I just wanted to emphasise that was a pretty good result, and it actually indicates that you know, to some extent that DIN target may well be attainable, and that we're on track. And I'm confident that with the investment that's coming into the region moving forward, there's a pretty good opportunity there for growers to get involved in, you know, further work that'll continue that progress.
Thank you, Rob. Now I'll invite Dave to ask his question, and I can see, Brock, you've got your hand up too. So if we can hear from you now, Dave, thank you. I think you're on mute, mate.
All right, there we go. Yeah, I just got a question. The Yongala, it sank 110 years ago, just 10 k's off Alba Beach, and shouldn't it be covered up, fully covered up with sludge and sediment? And yet it's voted to one of the best dive sites in the world.
Yeah, but everything moves. So we get a lot of resuspension of material too, which is one of our challenges when we look at using remote sensing, for example, because you can see you get turbidity from a river flood, and then you also get resuspension of that material over time. So the deposition of material on somewhere that like Yongala is probably not going to stay there for very long because of the northward movement of currents. You get wind and wave effect, and eventually that gets moved out of the system of that site. That's not the same everywhere. We do get build up in some of the more inshore locations, probably north of the Burdekin plume, but the Yongala is quite it gets regular flushing in its location. We've got some neat modelling that can illustrate that too, which I could probably get.
But wouldn't the water from down south from here go up our way as well, like from Mackay and Bowen? And where does the water go from out of the Burdekin? Like, where does all that end up?
So the material out of the Burdekin largely travels around to the north, so it goes up to the Palm Island group, and as I said, in those really large events it'll go further than that.
Yeah.
It's really only the fine sediment materials that will get carried long distances. The coarse material will get deposited closer to the river now. In terms of rivers coming up from the south to here, the rivers south of here, so the O'Connell, Pioneer Plain, Proserpine, they're significantly smaller than the Vatican. So we do see some flood plumes come this way, but so for example, you might get some material into Cape Bowling Green from the Don or the O'Connell River on occasion, but it tends to be carried with the currents further along the coast.
All right. I just think it's been there for 110 years and it's a pretty good model indicator. That's all.
Yeah, and it would, and it's good. It's good to show that we aren't getting that deposition in that location, which is also an important piece of evidence. Nutrients behave completely differently, of course, and that's, I guess, one of the greatest concern from the lower Burdekin, and they tend to be dissolved forms, so they'll travel further along the coast, but they also get diluted as they're in the water body for longer. So yeah, as you say, sediment's a good location indicator for us to get an idea of where stuff's settling and how often it sees those materials.
Okay, thank you.
Thanks, Dave, for that question. Thanks, Jane, for the answer. Can we hear from Brock now? And then I can see Greg's got his hand up too.
Yeah, thanks, Jane, for that presentation. There's some bits in there that I haven't seen before. Looks like you've got some new stuff that you're presenting, which is good. I've actually seen, I recognise that boat when you put the last slide up, and I've seen those blokes at the ramp absolutely flogged from being out in 20 knots doing their sampling. I didn't realise that's what they were doing, but a couple of times there, I think they've earned their PAVE check for the day. But I was just interested with that data you presented, like how much of that information, which, you know, could be considered like real-time water quality monitoring data, gets fed into that report card? Like what percentage is it modelling from paddock to reef versus, you know, modelling from the work that's been done through that project?
Yeah, good question, Brock. So the full water quality, not very much of it actually is used for the final metric. So the water quality metric in the report card is based on an eReef's modelling output. You see though, and the metrics that I presented for water quality are site-based. So they're based on our in situ water quality monitoring of the people going out in those rough conditions. There is good correlation between those though, but the scoring is done on the eReef's modelling for the whole Great Barrier Reef. And for coral and seagrass, it's obviously only based on these two data sets.
Okay, thank you.
Thanks, Brock, for that. Thank you, Jane. Greg, this will probably be time for our last question. So Greg, would you like to contribute your question?
Yeah, thank you. Thank you, Jane, for your presentation. I just got a query in regard to seagrass beds and their condition. It appears that that's been like a contributing factor towards our poor score in the Burdekin. And I was just wondering, to what extent is recovery in seagrass beds or health cyclical? how often does that take for that recovery to occur? And does the modelling sort of take into account the probability of recovery in seagrass? And then just finally, are there any monitoring stations in Upstart Bay in regard to seagrass health there, please?
Okay, so the first one, seagrass can seagrass can recover quite quickly, and you saw those cycles. In the Burdekin, some new work done by Stephen Lewis and Catherine Collier through the National Environmental Science Program, they've looked exactly at that question of how different flood events and different size flood events can influence seagrass condition, and they looked at Cleveland Bay, and they have found that it's the larger events that occur one after the other that are really damaging seagrass communities. If you just get a flood event and then you get a couple of years of reprieve, the data is showing and the condition shows that they will recover. So you get the right environment for them, like they're a grass. If they've got enough light, they'll tend to grow back. So that's a positive story for seagrass. There's no sites in Upstart Bay. What was your other question? Sorry, Greg.
I'm just not quite sure how the modelling works in terms of allocating a score at the end of the day.
Yeah, okay.
Does it factor in any sort of probability of future recovery at all?
Well, I guess the reproductive effort and the seed bank is a good indicator of potential recovery, as so there's abundance, the seed banks and then the tissue nutrients, and so they are probably the indicator of resilience that is used in the marine monitoring program for seagrass. So when we're seeing poor generation of seeds or low seed bank, we can see that the probability of recovery is probably going to be slower. There's just no seeds being produced. The modelling, do you mean in terms of the targets specifically? So that is based, the targets for end of caption suspended sediment loads are linked to seagrass specifically, I suppose, and the amount of light. So it's a light metric that we use for developing the ecologically relevant component of the suspended sediment target.
Thank you, Jane.
All right. Now we're coming into a presentation from Catherine.
Hi. Yeah, I'm just trying to start my video. Hi, everyone. I'm Kathleen Limaraju. So I am from the Water Quality and Investigations team within DES. I was actually really hoping to come up and see you all in person this time. I'm kind of been attacked by the coronavirus lockdown. So sorry, everyone, for that. I was really looking forward to it. You may know my teammates, Dr. Ryan Turner or Rowan Wallace, probably come up to do these science forums with you all, but I've been in the team for about 3 years, so I'm hoping I can stand in their shoes and give you the info that you're hoping for. Just a heads up, throughout this presentation, I've actually done true COVID style and put in some QR codes for you to scan. So these codes will link to some of our reporting products and new things that we're getting out there in terms of open data for you all to see. So if you can, maybe keep your camera phones ready and you can scan those codes. But yep.
Report on the water quality monitoring.
Sorry, I didn't hear that one. Can you say it again?
Sorry, I think I might have actually muted Michael. I thought that was an accidental.
I think Mark may have been speaking to someone else in the room, Kath.
Yeah, I was thinking that might be an accident.
Oh, okay.
Sorry.
Sure.
Yeah.
So when I've got my presentation up, I can't see anyone, so apologies if I miss anything. Okay, so just a really quick overview of who we are. So within the Paddock to Reef program, water quality and investigations kind of sit in the middle there. So literally the two in the Paddock to Reef program. So we take water samples and monitor nutrients, sediments and pesticides across Queensland. We produce pollutant loads data and also the pesticide risk metric, which I'll get to later. We track long-term trends in water quality, and we also provide data back to the modelers to validate the models. Our monitoring objectives overall are to provide concentrations and loads data to calibrate and validate the source catchment models. Those models are the ones that, obviously they try to remove the noise from interannual noise from climate and look at long-term improvements. We provide the monitoring data to help validate that. And as you can see in that plot there, we do tend to help them. They take a lot of information from stakeholders to develop those models. There is always that back-end step where we look at how well those models match what's going on in the real world, and we try to tweak them to make sure that they actually match what's going on out there, and they do extremely well. Our monitoring objectives are also to provide water quality data for the regional report cards. Now, the Reef report card looks at progress to target and change. The regional report cards are about current state. So our data goes directly into those regional report cards, both the loads and concentration data. So we also provide verification for the marine monitoring program results in the Reef report card. How do we do this? So there's one of the Scan Me little QR codes. If you want to whip your phone out and have a scan, please let me know if it doesn't work. That particular QR code goes to our recent story map. So, yep.
Catherine, sorry, can I interrupt you? You've got a little message down the bottom that's actually interfering with the QR code. Can you see the hide? That's it. Perfect. Thank you.
Yay, cool. Sorry, I wasn't sure you could see that. Okay, so we monitor 25 basins out of the 35 across the GBR catchment area. At 65 sites, 57 of those are used where we sample nutrients and sediments. We also overlap a little bit and sample 31 of those for pesticides. We monitor approximately 92% of the TSS load and 88% of the dissolved inorganic nitrogen load discharged to the Reef lagoon, and also the majority of agricultural pesticide inputs. So that the story maps there that is linked on that PowerPoint is to our annual story map report, where you can look at the actual loads and pesticide risk metric across the last few years. Interesting read, and it's all built on interactive maps where you can go and kind of interrogate that data and have a look for yourself where we're monitoring and what those results look like. We do a combination of just looking from the top left and going clockwise, in situ grab sampling. We have automatic samplers set up within our gauging stations, which will pump samples and refrigerate them until we can get there. And that's really quite useful to initiate those samples remotely from the office. At the river end there, you can see there's a bunch of equipment. So we have some probes sitting in the water that measure continuous real-time data like TSS, or sorry, turbidity, NTU, dissolved oxygen, conductivity, things like that. We also have, so there's a example of those probes there. That one that says Trios is actually a nitrate probe, which is pretty fancy. The one underneath that is an exosonde, and there's a few different probes on the end of that. So we've got conductivity, turbidity, temperature, and a couple of other bits and pieces depending on the site. That blue and red thing that looks like bug eyes is actually an acoustic Doppler. So that tells us how much water is going past and also how high that water is getting. You can see a nice photo there of some of our crew installing one of our new microsites, what we're calling them. So these are sites we can install in about half a day, and they automatically telemeter real-time data back to us in the office, so they're pretty handy. Bottom left, we've got some of our crew also out on boats doing gaugings of the river, so we can get the, I guess, the symmetry of the stream once we know that shape. And with those Dopplers, we can see how much water is going past and how high the water is getting. We get an idea of the discharge as well. Very useful parameters for calculating loads for our results. Everything we do under a quality assurance and quality control framework. We have NIDA certified labs. We have a range of trip blanks, field blanks, quality control solutions. Everything we do is according to standard, and also we run training for our partners so that they also operate under the same standards. Of course, we couldn't do what we do without the help of our collaborating individuals and organisations. Of course, in the Burdekin area, key to that is BIFMAC. So a huge thank you to BIFMAC, including Rob Ritchie, Luke Buono, Dennis Stubbs, Arwen Rickett, and of course, Aaron Davis from Tropwater as well. Okay, I'll jump into the monitoring results. As you saw, I think when Carl did his presentation, we had a look at these end of catchment targets. I've just popped these in here for the Burdekin again, and we can see for dissolved inorganic nitrogen, we have a % reduction target of 60% for the Ross, 70 for the Horton, and 60 for the Burdekin. Moving across, we've got fine sediment, particulate phosphorus, and particulate nitrogen reduction targets of about 30% for the Burdekin. On the very right-hand side there, we've got the pesticide target. So as you're probably aware, under the Water Quality Improvement Plan, we've got targets for sediment and nutrients that are amount-based, so load reduction targets. The target for pesticides has shifted to a more ecologically relevant target of 99% protection of species. And I'll get into that, what that really means later. In that very right-hand column, you can see the Horton River has been given a target of high management priority for reduction of pesticides, and the Burdekin is low priority. The other squares, the other cells are grey because at the time of developing these targets, we didn't have enough information in terms of modelling and monitoring in those basins. Just a heads up, we now do have that information. So couple of years ago, when in line with the change of the pesticide target, DES, so water quality investigations, with the help of OGBR and the modelers and DAF, we went through a process of developing a pesticide risk baseline. That's where we used real-time monitoring data for 3 years. Sorry, not real-time, real monitoring data across 68 sites across Queensland for 3 years. High-frequency pesticide sampling data across a variety of land uses for areas where we actually do monitor. We took that data and a range of explanatory variables like land use, climate, and spatial variables to try and explain those patterns in pesticide risk. Once we had some really good statistical models for that, we then applied those models at the basin scale for areas that we don't actually monitor. And I've just got the results there for the Burdekin area. You can see there's no huge surprises. So the Horton Basin was a high risk to pesticides. That's what that orange means. And the Don and the Black are very low risk. The Ross low risk and the Burdekin low risk. So no huge surprises there. Just want to give you a heads up that we have that data now. When the targets are revised, you will probably see those cells in that column and that table for the end of catchment targets filled in, but I don't see there being any surprises. You know, the Horton River will still be a high priority for pesticide reduction. The others will be low to very low. Okay, so I'll get into the loads results now. We have a range of sites across the Burdekin region for where we collect nutrients and sediment samples and where we calculate loads for our story maps, our annual reports, and also to help validate the models and to feed into the regional report cards. We've got one site in the Black Basin, one in the Ross, 2 in the Horton. So one on the Horton River itself and one on Barada Creek. We've got 5 sites within the Burdekin, so end of catchment and then some upper catchment sites. It's just such a huge catchment that we need some extra monitoring up in the upper reaches to understand how that system operates. And we've got 1 site in the Don. Just a quick refresher, the total amount of load or the amount of those constituents in the water can be influenced by a few things. So discharge, you know, we have low flow systems probably aren't carrying too much of a contaminant or a constituent like sediment or nutrients. Under high flow conditions, obviously that water is going to carry a lot more. It's also about the concentration itself. You can have a huge flow event with very little of that parameter in it, like sediment or nutrients, and you won't get a high load. So it's also about concentration. Catchment size is also really important. How much water is that catchment collecting and pushing out towards the reef lagoon? It's also about what's happening in the catchment itself. So erosion, catchment condition, the types of land use in there, geology, and of course, climate. You know, we can't really do anything to prevent there being a wet year or a dry year. It just happens. Sediment runoff is really important, as Jane was talking about. That sediment, like fine silt and clay, can travel into the reef lagoon. It can form flocks with the organic matter that's already there. It can stress the ecosystem out by blocking light. It can smother seagrass and corals. It can reduce oxygen and pH levels as well. So can be problematic. And of course, we also want to keep that sediment, that soil on the land where it's supposed to be, where it can be used for valuable farming. The story across the Burdekin is pretty much the same as it has been. I mean, this year, the latest monitoring results we have for the Burdekin region for loads, it's pretty beige really in terms of the story. It was a dry year for 2019-20, nothing out of the ordinary. And the loads that we have calculated for 2019-2020 actually fit well within the long-term averages. So I'm going to show you these plots because I think they're more useful in terms of telling that story. Here you can see mean long-term annual flow in megalitres per year, and the Burdekin Basin is bottom left there. So, sorry, Burdekin region, and the basins are in different shades of grey, which is really useful. But the Burdekin River is that larger slice of the pie, that one that says 13%. So in terms of the entire Great Barrier Reef catchment area, when we're looking at monitored discharge combined with modelled, so we can get a picture of all the areas, not just the ones we monitor, across the whole catchment area, the Burdekin Basin contributes about 13% of the mean annual flow per year. Look at the same basins across the GBR catchment area, but now we're looking at modelled loads for total suspended solids, so sediment. And you can see that now on the bottom right-hand corner, that light grey slice of the pie, even though the Burdekin Basin contributes about 13% of the flow, it actually contributes about 42% of the total suspended solid loads to the Great Barrier Reef Lagoon. I put a little asterisk there in the brackets up the top because this data is actually 2006 to 2018, but the 2019 to 2020 results actually fit really well within this. So it wouldn't change. Vatican at Home Hill, this is actual monitoring results. I just want to kind of tell the story about the sediment transport at this site. So what you're seeing there is a plot of calculated daily loads in the red bars. So this is based on a TSS, sorry, it's actually, I'll just backtrack a little. This is based on a probe we have sitting in the water, like you saw those pictures with the river and all that instrumentation. So there's a probe for turbidity, which is NTU. We can do a quick calculation and equate that to sediment, amount of sediment. Once we have that and we know how much water is moving through the system, we can calculate a daily load, so an amount of sediment coming out of that catchment on a daily time step, and that's those red bars. On the right-hand side on that axis, you can see daily discharge in megalitres, and you can see that the amount of sediment coming out through that system is really quite closely related to the amount of water. So more water coming through, more sediment coming out. So similar story for dissolved inorganic nitrogen for the Burdekin. There's close correlation with the amount of DIN and flow. So that's no huge surprise. We know that about that system. Go across to the Horton Basin now at our Barada Creek site. We can see a similar relationship between sediment loss and discharge. That we see bigger flows, we see more sediment coming out of the system. That's fairly well understood for the Barada Creek system. But dissolved inorganic nitrogen is a bit different. This particular basin those two parameters, dissolved inorganic nitrogen and flow or amount of water coming out, don't correlate very well. There's a pretty poor relationship between the two, and you can see that plot on the right-hand side basically says it doesn't relate very well. We think this is due to the timing of runoff. timing of those inputs like tailwater runoffs and groundwater inflows. It's quite a different type of system, and we realised on talking to our stakeholders and to talking to you all that we needed to know more about that. We know there are innovative practices being undertaken, like targeted fertiliser application, retention dams for reducing tailwater runoff, projects to enhance wetland function and improve nitrogen management practices, RP161 as well. The question is, can we provide data in a more timely manner to help you identify where those improvement efforts are most needed? It's all well and good looking at annual results, but what about actual practice in real time? Can we have a look at data that can help us understand those, the delivery of those constituents to the waterway and help us reduce that and keep that sediment, those sediment and nitrogen where it's supposed to be? So to that end, we've started a new project, and many of you would have been involved in the workshops around to get this project off the ground in terms of where we place these new sites. So we've actually coined a new term, and this is Ryan's term, called Microsites. And basically these are those little sites that we can install in about half a day's time, compared to our normal sites, which have a whole shed, a cement platform, a heap of equipment in there, including automated fridge samplers and all of that stuff. They take about a week. These ones are quick. Pop in, establish the site, put the probes in the water, make sure it's talking back to remote telemetering the data back to the office so we can see what's going on. And we're just collecting real-time data, supplemented by grab samples to make sure that real-time data is actually within the appropriate range and to calibrate that equipment properly. So this is the RP232 project, which we're calling it, but it's basically where we've installed a whole bunch of new microsites within the lower Burdekin region, with the sole aim of trying to understand that water flow to nitrate interaction, where that nitrate's coming from. As you know, nitrate is one of the components of DIN. Where's that nitrate coming from? How can we understand that loss to the system and perhaps look at ways we can reduce that loss and reduce the impact to the Great Barrier Reef in the long run? So we've installed now a total of 15 new sites in the lower Burdekin. We've got 5 more to come. Each of those microsites has a nitrate sensor, that little trios sensor that you saw in the previous slide, a sediment sensor, which is actually turbidity, but we can make a quick calculation and relate that back to TSS, and stream level. So I've just put up a plot there for Plantation Creek, which is that one, the little red dots just come up at Old Wharf Road, just as an example. And you can see at the top there, we've got nitrate concentrations. And at the bottom, we've got stream level. And you can see this kind of interesting dynamic where as the stream level drops, you get more of an interaction with that groundwater recharge, and you see the nitrates coming up. More water in the system, more fresh water coming through, and the nitrate signature just drops right down. So we do see that interaction at quite a few of these sites, which is really interesting stuff.
Catherine,
all of that data.
Sorry, you've got about 5 minutes left before we go to questions.
Oh, okay. Oh, right, okay. I'll try and hurry through this. All of that data is available on the 1622 app. There's a little QR code to scan there if you'd like. I'll show it at the end as well. Pesticide sites. We've got 7 pesticide sites in the Burdekin region. As you know, the pesticide target is now to protect at least 99% of the aquatic species at the end of catchments, so it's a more ecologically relevant target. Concentrations themselves can't tell us too much, only if those concentrations are above or below targets, guidelines, which doesn't tell us how much worse those ones at the top are compared to the ones at the bottom, for example, for the ecosystem. Plus, there's usually a lot of different chemicals involved, in the water at one time. And how do those toxic impacts add up? Pesticide risk metric includes 22 priority chemicals under the WQIP. I won't go into this too much because I don't have much time. Happy to chat to people afterwards about why those chemicals have been included and their individual toxicities. From that metric, which we're calling the pesticide risk metric, which was developed to be able to report against that target, that pesticide risk metric actually combines the toxicity of those 22 chemicals into one value, which is the annual average wet season risk. And because we've used the same method to develop that metric as was used to develop the guidelines, national guidelines, we can use the same risk matrix over the top. So it's basically a standard red to green traffic light system of risk. These are the results for the 2019-2020 Burdekin region. I've just put them there in context of all the previous years that we've calculated using this metric. No huge change. In fact, Barada Creek at Northcote has dropped down in risk slightly from very high to high. Slight increase in risk at the Horton at Girrawee Tailwater site, which is the end of system site, but that site fluctuates around the cutoff of that risk section anyway. So no huge surprises there. Just breaking that down a little bit, we've got percent protected on the very right hand side of this table. The colours are those risk scores. The red and white section there is about how much of those individual chemical groups, so insecticides, other herbicides and PS2 herbicides actually influence that risk. So the systems, I probably wouldn't pay too much attention to the very low risk sites, but the systems in the Horton Basin, the high risk and moderate risk, the yellows and oranges, that's driven primarily by PS2 herbicides and to some extent other herbicides. Just breaking that down a little further to individual chemicals, because with this metric we can actually look down to chemicals themselves. You can see those two bars that are a bit higher, Barada Creek at Northcote and East Barada Creek at Joanna Road. Those risks are actually driven primarily by diuron and atrazine, a bit of metolachlor and some imazepyc. I'm happy to get this plot out to everyone if you feel like it's needed. And of course, within that system, we do tend to have land use that's predominantly sugarcane and horticulture, for example, mangoes, which we know tends to be related to, seeing those PS2 or photosystem 2 inhibiting herbicides like diuron and atrazine. And we now have instantaneous reporting of lab data to the public. And I remember standing in front of you all 2 years ago going, I know we give you exceedance reports, but I know you want to see the other side of the story. Where are the good news stories? Well, this is it. We've spent a year making this product. I'm going to give you a link to it shortly. We're no longer going to be issuing paper, PDF, exceedance reports because we want you to see all of the data. We've built a platform where you can go in and have a look and play with this data yourself. This platform includes 24 different pesticides, including the 22 WQIP reference chemicals. The data is visible to you as soon as it's released from the lab. There's a few guidelines in there, including the PC95 guideline. You can see that line at the bottom of the plot. There's also, which is the ecosystem protection guideline. There's also irrigation guidelines and drinking water guidelines where they're relevant. You can interact with and interrogate this data, and I'm happy to catch up with anyone afterwards. Perhaps if anyone's interested, you could send Renee or Jade a message and I can do a little workshop and show you how this platform works, because I'd actually love your feedback as well. So I'm just showing you diuron and atrazine for the Barada Creek system, and you can see the influence of those. This is about 10 years of data, the high flow events during the wet season and that early season increase in chemical concentrations and runoff. And this one's for atrazine. So this is the platform. It's the pesticide reporting portal. We're very excited about it. It literally released last week, so you all are the first people to see it. If you're interested, please scan that QR code. It will take you directly to the portal. There's an interactive map. You can click on things. You can go to the data and interact with the data within our database directly in the form of plots. Again, I'm happy to do a little workshop with people to show you how that works. And that's it from me. Thank you. I've got those QR codes there if people would like them.
Okay. Thank you, Catherine, for that very detailed presentation. And I can see that there is, which is great, I can see that there's a lot of detail on those slides. So we might get in touch with you afterwards, if that's okay, and just check if it's right to
sure.
Slides to others so they can have a look at that session. That's great. Now, I can see that there are a couple of comments and questions for you in the chat, but I would like to just open the floor for the next 10 minutes or so if anyone here has any questions they'd like to ask you verbally. Can I get a show of hands or use the reaction button down there? Okay, I can see Michael's got a question.
Yep.
Yeah, Michael, would you like to go ahead?
Oh, hi, Catherine. Thanks very much for that presentation. That certainly enlightened me on a few issues. Just wondering, one of the issues we've raised previously is about the location of the rain gauges or the water measuring, and also then the water quality. And as we understand it, they're often not located at the same place. So,
yeah. Well, for Michael, for loads calculations, they are usually located at the same place. Because we need that combination of data to be able to calculate the load. So we have concentrations, but you also need a gauged system and know how much water is coming through it. Those locations are also by design in the same spot as the modelled nodes where they validate for that particular site. So it's very easy to kind of, you know, look at the similarities in that data and make sure they match up. For pesticides, it's a bit different though, because the target for pesticides in the WQIP is end of system, and it's very difficult to accurately gauge a waterway at the end of system. But for pesticides, we don't need discharge necessarily to calculate that metric. It is informative when we're trying to understand the results. So we do have a range of data that we pull in to be able to do that.
Thanks.
Okay, thank you. Just going to leave a space here for any other verbal questions.
Yep.
Okay, I'm not hearing anything, Catherine. Now you've got a couple of comments here in the chat that you can probably see where you are. So there's one from Brian who says that the majority of the upper Burdekin catchment is naturally highly sodic dispersive soils, which accounts for the turbidity and why sediment stays in the suspension. Yeah, did you have any additional comments you wanted to make on that?
No, that's absolutely right. Okay. Yeah, we do tend to see, you know, as with most systems, particularly large ones, where that water slows down, you do get some settlement down in the system, and you can see that difference when, if you go to those story maps in particular, you can see it really nice visually. You can see those upper, I guess, nested catchments in the Burdekin have comparatively quite high loads for sediment. And then if you look at the overall Burdekin, it reduces, and that really is about dilution, but it's also that sediment within the catchment lower down. So yeah, you're absolutely right. Again, what we're looking at here is monitoring results, not modelled results. So you should be able to see those patterns in the data.
Okay, thank you, Catherine. And there's another question here from Pioneer Cane Growers about why are there not more sensors placed upstream as requested by Pioneer Cane Growers Association?
Yeah, is that for the RP232, the new microsites, I'm guessing? Yeah, yeah, so we only had, it's a good question. I think we wish we could have a whole bunch more sensors. We've got funding for 40 altogether. So we're putting some in the Herbert catchment and some in the Vatican. Through the consultation and those workshops, we did identify a range of upstream monitoring sites to be our reference sites, and we have included those, but there are another 5 to come in. So I think there's another reference site. I'd have to check with Ryan and get back to you exactly where that is. We did have to prioritise where we put those sensors based on a couple of things. So there was the number of sites that were suggested by the stakeholders, and this is all really driven by the stakeholders in terms of where that data should be collected and where those patterns might be and where we might be able to, how we might be able to understand more about the system. So in some cases, it was actually quite a double up, and we'd get, you know, 5, 6 suggestions of placement for a sensor, which was exactly the same. In those cases, we definitely prioritised that spot. It was obviously needed. There were a range of other ones that would have a single suggestion. Then we had a look a little closer to see what the value would be of that placement, because we really had to prioritise getting the info upstream but also getting enough info downstream too. So there are some upstream sensors. I'd be happy to chat to Ryan and get the location for the last 5. Yeah.
Okay, thank you. I can
That's
see
okay.
Michael's hand up. Any other comments before we go to Michael? No. Okay. Go ahead, please.
No.
Michael.
Yes, thanks, Renee. Look, I just wanted to emphasise what Pioneer has just raised, and that is, I know, Catherine, you were saying that the location of the monitors is driven by the stakeholders, but there were quite a large number of stakeholders wanting those monitors at the top end of the catchment, because it was really important to show the quantities of materials coming into the areas versus the end of catchment runoff. And a lot of individual farmers have actually gone to great expense to engage their own water quality testing people to come out and run tests. And they've proven that on their own particular farms, the quality of the water that comes onto their farm improves as it goes off their farm. And I know that's on an individual farm basis, but if you apply the same model, we think it's absolutely vitally important that those monitors get placed at the beginning of the catchment, and then therefore to be able to monitor, if you like, the change or the difference. That's one comment. And the second comment I'd make is, I look at your graphs with those spikes, particularly around, you know, single major rain events. And I sort of look at it and think, wow, farmers are being asked to change their entire practices for 12 months for the year in the event that there may be a rain event. In a dry year, all the levels are low. And as we know, the water doesn't run into the rivers. It sort of runs the other way off the farms. So I just wonder I suppose the fairness in having to change practices and do all of those things for those occasional rain events. It would be nice if somehow those farm management practice guidelines or requirements were only related to the wet weather seasons, if you like.
Yeah, it's a good point. I'll address the microsites one first. And I apologise because I wasn't heavily involved in that project. So I think what I need to do is get a bit more information and get back to you. I'm aware of at least one, but potentially two very good reference sites that have already been installed for the microsite project. But what I'll do is I'll get back to you with some more information from Ryan about those proposed sites. I agree. We've got to see what's coming in from upstream to be able to understand what's happening downstream. We are not targeting individual farms, unfortunately, because we don't want anyone to be unnecessarily identified or vilified through this project. It's about whole of system function and what's going on out there. So, but it's also about getting the data back to you, to the landholders, to the stakeholders, to be able to make those decisions. I'll just reiterate that this is monitoring data. We can't take out that climate signature. And we're not looking or reporting on progress with this data. We're looking at what's actually happening out there, its current state. So when you look at those climate signatures and those large rainfall events, you know, it's particularly useful if we do look over a longer time period to see those interactions. But what we're hoping is for the water quality investigations team is to actually try and form that bridge between the modelling and the management practice side of things and give you the data that you need to maybe inform those practice changes. We're not about, you know, trying to enforce anything or make you change what you're doing, but it's about giving you the key information you need to see what's working and what isn't. You know, we're hoping that by opening this data up to you, you can actually see where, you know, some of those losses are happening. And for example, you know, spending good money on pesticides and fertilizers. You don't want it going off into the waterway. You want it where it's supposed to be and where it's been put so it can do the work it's supposed to do. And we need you to have those chemicals in your toolbox still so you can produce good crops. We're not about removing those, you know, those levers that you have. It's just about giving you the information you might need on the ground to see if those management practices make sense. And maybe there's more bang for your buck to target those first flush rainfall events to try and, you know, capture some of that sediment or the nutrients or the pesticides and not let it run off. And in that way, you won't see those risks at the end of the catchment. You won't be targeted as much, you know, in the report card. So if we can do all of that and we help each other, then maybe we get those wins that we're looking for.
Kathy, Adam might be able to talk to some of those practice questions as well.
Yeah, sounds good.
Yeah, that's right. Yes, which is a nice segue into our next speaker, who is Adam. Now, before we go to Adam, thank you, Catherine, for that presentation, and thanks to everyone for your questions. Good discussion.
Thanks, everyone.
And I'm just going to invite Adam now to start getting set up for your presentation. Thanks, Adam. Welcome. Oh, look at you. Look how tropical you are.
Oh, yeah. I'm definitely sitting on the beach and not in my office.
No, it's not a virtual background at all.
No, I'm definitely on the beach. Yeah.
All right. We might ask you to kick off, Adam, whenever you're ready.
Yeah, no worries. So my name's Adam Northey. I work for the Department of Agriculture and Fisheries, based in Rockhampton. Work with, many people know of Kev McCosker. He's the team leader of this program, so I work with him. I've been in this program now for a bit over six and a half years or something like that. Before that, I worked for NRM groups. I worked for worked for Fitzroy Basin Association, so sort of been tied up in this reef space now for over 10 years. So the part of the program I work in is in the paddock to reef area, obviously, and in the management practice adoption program. So the management practice adoption program's got a few really key points about it. The first one is to monitor the adoption of improved land management practices and systems, and report on the land management target. So the current target is this one that's here in the brown, 90% of land. 90% of land in priority areas under grazing, horticulture, banana, sugarcane, and other broadacre cropping are managed using best management practice systems for water quality outcomes, soil, nutrient, and pesticides. The other big part of what we do is we provide the data to the modelling teams, so the paddock and catchment modelling teams, and Mark's coming up later to talk about that. So we provide the data to them to be able to manage the change, to be able to represent the changes. So a landholder makes a change with support from a reef program, NQ Dry Tropics or somebody like that. I've done some work with them. They report that to us. We report into the report card and also provide that data to the modelling team, who can then model the impact of those changes. The other sort of secondary sort of things I guess we do around providing feedback back to the investors. So the Queensland government, the Australian government, and Great Barrier Reef Foundation about the effectiveness of their investments. They all seem to be driven about what did we buy sort of thing. So it's becoming quite a big part of what we do. And we also try and provide and support delivery organisations as much as we can on how to be more effective. So at the end of the day, you guys are the ones out in the paddock trying to get the practice change, help, improve efficiencies and all those sorts of things. And it's sort of our role to try as best as we possibly can to tell that story into the report card. Doesn't always fit nicely. We've got to have a one size fits all sort of system, but we try our hardest, and if ever you have any issues, just talk to us. So what I thought I would do today and talk about is land management targets. So in the agenda, it says I'm going to talk about the questions and where they came from and how they got there and all that sort of stuff. So I'll go through a bit of a process here about the questions and what they are, and then also, how they're driven by these land management targets. So the land management targets, that one I showed before, the 90% adoption, that really drives the information that we need to collect to be able to report. So, and as Carl said earlier, those targets are being reviewed now. So that rather than go through the process too much today, I'm going to talk more about these targets and the evolution of them and how that's influenced the questions and the data we collected. And then towards the end, we're going to talk a little bit more about, well, what's the future look like? And, what are the sort of things that we might be interested in into the future? Okay, so the first water quality or reef plan, I think, came out in 2003, but it was sort of more about a let's coordinate some efforts, fill a few knowledge gaps and all that sort of stuff. So, you know, groups like NQ Dry Tropics and the industry groups have been sort of working on, you know, sustainable farming practices in the reef catchment for quite some time. And 2003 was an attempt to try and coordinate some of those efforts around water quality. Now, in 2009, this document came out, and this document was the Reef Water Quality Protection Plan 2009. It also coincided with the reef rescue investment, and this is where we first seen land management targets, and we also have these load reduction targets here. So that box in the middle there, by 2013, 80% of landholders in agricultural enterprises, sugarcane, blah, 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 have adopted improved soil nutrient and chemical management practices. So improved practices. And then these are the loads targets that were developed about, well, how much less nitrogen and pesticides and sediment do we need to remove from the system to create that resilience out on the reef. So with this, back then, none of the reporting was spatial. So we weren't, people now know that we're interested in where the farm is, and we have a whole series of questions. We weren't interested in that back then because this target was just about people improving practices. What we were interested in is how many landholders are engaging, also how many new landholders are engaging as well. So that target being 80% of landholders have improved their practice, that really set up the way we were. That meant we were interested in how many were coming, but also how many new ones were coming. And basically the plan to know when we've met this target is we have a bit of a rough estimation of how many landholders there are in a particular area. So based on ABS, Australian Bureau of Statistics data, talking to peak bodies, local knowledge, NRM groups hold a lot of that knowledge as well. So, we got a bit of an estimation, then we just count the number of people that engage. And that then tells us how close we are to hitting that 80% target. There was a few issues back then that meant we had to rethink this target and why ultimately it ended up leaving. There wasn't really a good way to know whether we were double counting some of the savings. There was also a real bit of a scattergun approach to targeting practices. So some projects targeted big changes, some were quite small, sort of scattered throughout the catchments. So in the cane area, this doesn't really matter where you kind of work in the catchment, but in grazing, there's quite a big difference between working right up the back of the Burdekin catchment, say alpha, compared to down the bottom sort of thing. Like the amount of sediment generated from those two sites are quite different. So this is an example of what the reporting was back in 2013, 14. So basically project one, they all had their own project IDs. Landholders had their unique ID, like they would get a unique ID in the system. We'd get an idea of the area, a bit about how much money was spent, so how much was reef rescue funding, how much was landholder cash, and then a description. And that was kind of all we really had then. But this worked for all we were interested in was engagement. So we were just adding up how many unique farmers we were getting here. One of the things we didn't really understand here is there was a modeling effort here too to try and see how we were tracking against that, reduction in targets and that sort of stuff. The thing that we didn't understand back here is this project here, project number 2, purchase and use a spray rig. How much improvement did that actually create? Was that Was that huge amounts? Was the old spray rig really clapped out and really inefficient and you know, putting on 10 times the amount of chemicals than needed? Or was this just a pretty small incremental improvement? So we really weren't able to gauge the amount of improvement we were getting from these investments. So in line with the program's designed that every 5 years there's a reset and a review of all the targets, and as the new information becomes available and new understandings, that sort of stuff. So in 2013, these new targets came in. So the one up the top here is changed to language that we're more familiar with in the current target. So 90% of sugarcane horticulture, cropping and grazing lands are managed using best management practice systems, soil nutrient pesticides in priority areas. So now we have a target that's talking about area and not about people anymore, and has mentioned this best management practice systems. Okay, so, and these targets around dissolved inorganic nitrogen and sediment and pesticide, some minor tweaks, but they're sort of still kind of the same as the ones we've seen in the 2009 Water Quality Improvement Plan. But the change in target meant some pretty big shifts in the information that we needed to know to report against this target. So as I said before, the shift to area, we now need to know area, and no longer account of landholders. Shift from needing to know, a shift from improved practice to need to achieve best practice. So that before any sort of practice improvement, anything, whether it was big, small, whatever, was counted. This time, it's about reaching a line that had to be developed. When this first came out, this was first developed, or first put up, we really didn't know how far or close away from that 90% we are. So, you know, are we almost there? Are we a long way away? So we needed to go out and do some work about finding out where, no, actually I'll show this up. Yeah, so there's two really important parts of this thing, 90% and that best practice. So that 90% means we need to know how far away from that we are, and 90% of lands. So how far away from that we are, and you know, how much work we have to do to get there. The other thing was best practice systems. So when this was first come out, nobody had ever defined best management practice systems for water quality, which is important to put in here in a lot of these areas. So the first of the water quality risk frameworks was developed. So this is the 2013 one. What this is attempting to do is describe the practices that can happen that influence the risk of soil leaving a farm here. It attempts to give a weighting to that and describe a few levels of adoption in this. You'll see here the nutrient one is about the varying levels of application of the 6 Easy Steps program, more or less, or 6 Easy Steps methodology, and also timing and application method. So the first of the water quality risk frameworks came out. This was the way that we were going to be able to go, okay, if you reach this line here, and we've defined it here as best practice, if you reach this line here, then you have met, we agree that you have met that target, and we can now count you towards that 90% of that land. Benchmarks. So we had to go out into the areas and try and do some surveying and local knowledge, local expert advice, and all sorts of bits and pieces to try and get an estimation of what percentage of the land is managed using those different systems that are described in the water quality risk framework. So knowing how far away we were. So these are the early ones. This is the ones that were in the 2013 or 14 report card. Basically described like this. So soil, how much is in this high risk, how much is in the moderate, and then this moderate and low. So these two here, this is the area here that we're describing as reached best practice. And a big change in the reporting at this stage. So because it was an area, because it's an area target, and not a person target, we needed to have something spatial about that area. We needed to know where that area was, so that we could track that area. We had a way of tracking the person in the previous one as the landholder ID, but now we needed to track that actual parcel of land. So that's spatial reporting became a thing. We also needed people to report against this water quality risk frameworks because we needed to know when they were reaching that line in the sand that was best practice. So that's when we started seeing this sort of stuff. So we would have a farm boundary sent to us. We would have the questions. So this is Cane, question 1, current Cane question 1 proposed there. It's where we started. This is when we first introduced reporting against risk frameworks. So this was great. So this now enabled us to see, we were able to look through these and work out where they came from, what were the practices they were doing before, and what are the practices they're now doing, and how much of an improvement that particular project has had. So that's how the reporting worked up until 2017, 18, when the new water quality improvement plan, and this is the current one now, and currently what's under and will be reviewed over the next few years. So the target that's in the current one is the one I read out before. Now it's pretty much stayed the same as in the last one. You know, we've refined the wording in it, but essentially it's the same thing. The big change in this one was there was now targets for the individual catchments. So went through the risk, the risk assessment process, and each of the catchments gets, you know, what's their priority in here and some individual catchment targets. What this meant for us is, in the past, we'd just reported at this Burdekin level. It now means that we needed to report at this individual catchment, so the Horton, Burdekin, Don, etc. It also brought about some slight changes to the water quality risk frameworks, because it's in that cycle. As the science improved and we learned a bit more, we improved. The frameworks evolved and represented a few new things into them. Reporting, there was a few background things about standardized reporting format. In the past, we'd sort of had reporting formats that were kind of all over the place, so we sort of left it up to the individuals on how they wanted to collect the data and send it to us, which sort of made analysis of the data as a whole a little bit hard. So we brought in some standardized reporting formats. So this is how, when you send it to us, it needs to be in this particular form, and it needs to look like this. That really helped us improve the speed of which we were able to analyze the data, and I also believe the accuracy of the way we analyze the data as well. So because we weren't double handling so much data, there's less opportunities to make mistakes in the data the less you touch it. There were some updated benchmarks as well. So we'd gone back to that original graph and looked through it, worked with the local providers and gone, okay, well, does this reflect what's actually still happening on land? And, you know, we did some more surveying of different areas and brought in some new data. And so the benchmarks got updated a little bit. As I said before, we then needed to report at that catchment scale. So a little bit of stuff in the back end. And there was a further evolution of the paddock to reef questions to reflect the updated risk framework, but also about reflecting about the things that we needed to know, or the more the more advanced way of analysing data, I guess. So I'm going to go through a little bit now. I'm going to drill into some of the questions, the individual questions, and sort of show how these have evolved over time, and try and explain why they've evolved like they have over time. So sorry, I'm going to go back like this. Okay. So in 2013, these were the nutrient management questions. So question 6, sorry, I got somebody trying to call me, which is really mucking things up. So question 6 was about how far you implemented the 6 easy steps process, really. You know, am I looking for district yield potential? Am I doing it down to my own blocks and returns, so a block yield potential sort of thing? Variable rate inside of the block. We had some stuff here about timing. We also had some stuff about placement of fertilizer. What we later learnt was that timing is one of those things that nobody intends to have poor timing, but you know, when you work in a tropical environment, long range forecasting isn't very good. So you can have the best intentions around timing of fertilizer application or even pesticide application as well. And then you get a 150 mil storm that nobody knew about, and you have a bad outcome sort of thing. So we went, okay, well, that's maybe not something that we can have a huge amount of influence on. Placement of fertilizer was another one. Just about everybody in all of our surveys were putting it subsurface. It's like, well, are we actually getting any new information by asking this question here? So it eventually got dropped out. Okay, so the issues around the nutrient questions in 2016, 13, when these first came in, I think I've got a typo in the heading there, was that we assume the way that this was structured is the assumption was those first two had a poor water quality outcome, and that's not true. So science has proven this over the last few years that this isn't actually true. Using 6 easy steps, aiming for district yield potential, you can have good water quality outcomes. It's not a one size fit all sort of thing. So one of the big disadvantages was that this was treating, we were looking at the rate at which, well, we're looking at the amount of nutrient that was applied, and we're treating everybody the same regardless of the yield. Okay, so if you're growing 60 tonne and putting on 190, you're treated the same as growing 120 tonne and putting on 190. These two have very different water quality risks. So, you know, the 120 guy is taking up twice as much nitrogen as the 60 tonne guy. So very different water quality risks. So in 2016, we introduced a few more questions around that. So we kept question 6 pretty much the same, but we now were asking questions about what is your rate and what is your yield. Essentially what we were doing was we were using these questions here, this rate and yield, to try and line up to one of these questions above. Which was much better than what we were doing. It's still not perfect, but it was much better. So we were able to, that example before, we were able to pick apart that 160 and 120 a little bit and add just a little bit of movement between the two and try not to treat them the same. The issue here was that we were still defining the way that people should calculate their nutrient rate. But so we were still saying you have to use 6 easy steps. In reality, we don't really care how people are doing it. It's really all about the outcome, not so much about how you got there. So by defining this here, we're going, you have to be using 6 easy steps. If you were doing something else, you didn't fit into our system. So we dropped that question 6 altogether. So this is in 2018, and the ones that we're currently using, so most people will be familiar around these questions here. We just asked straight out rate and yield, okay? And then what we had sitting in the back end of this is we're going, okay, so we started looking, because really it's all just about how much nitrogen surplus there is in the system. So if the nitrogen's not in the plant, the nitrogen in the plant isn't an issue. It's in the plant, it's doing exactly what it is. What creates the risk is the nitrogen that is excess to what the plant can take up. So what we attempted to do was build some, we were trying to build a thing around nitrogen use efficiency. Back then we didn't have a real lot of, there wasn't any data about how breaking it up into a number of steps. So we had some stuff here around nitrogen use efficiency, what was really good. So, you know, 1.2 kilos per ton of cane is quite good. 1.9 kilos per ton of cane was considered to be not so good. But what we needed to do in the modeling is describe a whole heap of multiple steps here. So what we've done is try to break it up as best we can. Now this is, it works for the purpose we needed, and it's still not ideal. Where we're moving forward to in this area is we've drafted up, so we've been working with CSIRO here about reanalyzing a whole heap of data, so nitrogen response curves to rate trials, a whole heap of our data, and trying to come up some ranges. And you see here I've got NILRI, so it's nitrogen loss risk index. So nitrogen use efficiency, NUE, in all other crops, so wheat and corn and everything else is yield per kilo, whereas what we're sort of describing here is kilo per, or tons per kilo, where it's kilo per tons the other way. So it's sort of we're describing the inverse of nitrogen use efficiency.
Adams, sorry to interrupt you. You've got about 5 minutes to go before we have questions.
Oh, okay. Yep.
Thank you.
Okay, cool. So what we've got here, so we've attempted to come up some new ranges. So what we're hoping to describe is a little bit better the improvements through there, give it a little bit thing. We still know that that's pretty granular. So we've got 6 classes there. We'd love to have 40 because, you know, as you move up through that range, it's better, but we're sort of a little bit constrained with the modeling so far. So I'm going to just quickly race through this. So in 2013, we looked at just that question, C class. In 2016, we used the rate and yield to line up. So that would have gone, the same grower is now a C+. He's done a few reductions based on organic carbon, we believe. 2018, we've looked at, you know, what was his farm average rate and the yield. We use that 1.4 and 1, and we go, well, you know, his farm average rate is pretty close to that 1.4 and 1. So that's pretty good. The problem again is that it's linked to a practice. We're defining what practice you should use to come up with that. So we really don't want to do that. We want to be more about the outcome and not the practice. The future will be something, this NILRI or nitrogen use efficiency. Okay, so what I'll do is I'll skip over a whole heap of slides and I'll go to, and this is a similar story for pesticides. So we've gone through a process of describing the practices you should do and trying to assign a risk. Where we're going to with pesticides is using the same methodology Kath was talking about just before, about what is the pesticide, what is the marine impact of the mix of pesticides you're using. So, you know, we want to know the outcome. Irrigation will be a similar sort of thing. You know, we're describing all these different things. Really what we're interested in irrigation is how much cane are you growing with the water? So how much of that water is going into the cane? How much is flowing past, sort of thing? They're the things we're interested in. Now, new land management targets. So this document is due to be updated in 2022. In a statement from the Minister in February this year, she's made a commitment to bring the review of this target forward. So it's basically started right now and due to be finished, well, due to be drafted by the end of this year and then out for public consultation and all that sort of stuff. So if you read here, also announced a 5-yearly review of the Water Quality Improvement Plan, review of the land management practice targets, and industry and other stakeholders will be consulted throughout the review. So the issue with this target here is this kind of sentence, best practice management systems. So it means all systems. So it means nutrients, it means pesticides, it means soil. There's lots and lots of averaging in there. So there's lots of things there's lots of practices in nutrient management that make up nutrient management, you know, timing, place, rate, all of those sorts of things. So that gets averaged up and given a score. Pesticide, soil, nutrients. So there's lots of averaging. All of the funding is really aimed at just a couple of things. So we're interested in that rate, or, you know, actually what we're probably more interested in is that nitrogen use efficiency. We're interested in some irrigation things in the Burdekin. Like, they're the things that we know that make the biggest impact on changes. Oh, so those 3 things there then get averaged up again, and you get this E grade and a 13%. Like, this doesn't make sense. Nobody's investing in soil. So why should this drag this number down, drag the target, and you know, mean that there's no chance you'll hit this because, you know, it's flat in the Burdekin. There's not much of a soil issue there. So that's the problem with it. So we're really happy that this is being reviewed, because every time I do something like this, we get beaten about this target and about the slow adoption, that sort of stuff. The thing is, there's been really great adoption. So I'm going to really race through because I know I'm over time. So again, targets guide what need to be reported. So in 2013, the one was about projects. You know, in 2013, it was about the number of landholders. Okay. So we were just interested in the number of landholders. The new target was about land across all of these management systems. So then we have to ask a whole heap of questions about it and understand all of the systems and report against all of the systems. We have these targets already for what the things we're interested. So if we look at the Horton, you know, we're interested in DIN. We're not so interested in fine sediment and particulates. So, you know, why is there a fine sediment target for the Horton? Why is that forming part of the assessment and the grade that cane growers are getting for the Horton? So the idea, just quickly running through this, the idea is to look at, we just drill in on a few areas. So Burdekin River, and we look at the DIN. We look at the things that contribute to that. So, you know, improve nutrient management, improve irrigation management in sugarcane, horticulture and nutrient management, grazing land management. So, you know, there is a significant amount of DIN runs off grazing lands. We need to look at these and go, well, what is the scope? What is the impact of these? So horticulture is pretty small footprint, so the scope's is much smaller. Grazing land, you know, I don't know. But sugarcane nutrient management doesn't give you much to work with, right? So let's drill down a little bit further. So what are things that will improve nutrient management or improve this nitrogen loss index? So more efficient irrigation, you know, let's run more off it. Let's grow bigger crops as well with really efficient irrigation. Fallow management, there's some, you know, is that impacting on yields? Weed pressure, is that impacting on yields? Soil health, those sorts of things. So there's lots of things now that it opens up for targets. So targets in the future aren't going to be 90% adoption of best practice. We hope they're not going to be 90% adoption best practice nutrient management. What we're hoping for is around this, you know, 75% of, or 50% of the area has a legume fallow, or things like that sort of stuff. What's going to be really important with engagement in industry is what's actually achievable. So if we look at this one here, what are the things we can achieve? What are the things we can do, and what's achievable? And that's where you guys are going to become really important. And just lastly, it's in the statement, independent review. So it's not going to be us that sets these targets. It's going to be somebody independent. Our role in this is providing the data and some technical knowledge about this sort of thing. And it's also industry and other stakeholders will be consulted through the review. So it's going to be really important. And again, targets guide what need to be reported. So that's me wrapped up. Is there any questions?
Firstly, thank you, Adam. That is, we know it's a very complex thing, the modelling, so you've done well to try and get through it in the time allocated, so thank you. Now, you do have a couple of questions in the chat, but before we go to those, I'd just like to invite Phil to ask a question. I can see he's got a hand up.
All right, thanks for that presentation. You probably have one of the most important things to do that impacts growers, sugarcane growers. And I guess everyone raises, but I can only talk for sugarcane growers. So I can see a couple of problems. First of all, unless I misunderstood your presentation, a lot of your information comes from growers that actually apply for money from the government to make changes. Doesn't take into account, unless I've got it wrong, doesn't really take into account growers that do things on their own without applying for government funds. I'd really like to understand how you determine how many growers are at best management practice, because I might be going out on a limb, but I'd say 89.99% of the growers in the Burdekin Delta are already at best management practice. They might not be BMP accredited. I'm sure you're aware of the cane growers BMP, but that doesn't mean they're not management practice. It also doesn't take into account incremental changes over time that growers continue to take every year. Our systems change. And when you talk about an independent review, that sends a bit of a shiver down my spine, because at the end of the day, we all know that doesn't matter what the review says, it's going to be a political decision. And politicians have been shown that they're not afraid to beat us over the head. So yes, it's important that your work is done properly with the correct information. So I don't know if you've got anything to say about that.
Yeah, so I guess the thing to remember also with Reef Plan, and it's lost. Well, with paddock to reef in particular, which has been lost over the years, is it was designed to measure the impact of the funding that the Queensland and Australian governments have done. It's expanded a lot over the years, but that message has really been lost over the years. That was its primary role when it was first came out. So that spreadsheet I showed, which had all the money and that sort of thing in it, that's what it was designed initially to do. So the second part is we absolutely know that there is voluntary changes and that sort of stuff come in. So, and part of the built-in part of the program is that each 5 years, we reset those benchmarks. So we go out and we survey and we talk to industry leaders and all that sort of stuff. And we try and get a new adoption profile to account for those people that have made changes, but also account for the people that have regressed as well. So, we know that properties change hands and new growers aren't as interested in different things, that sort of stuff. So we see all of that sort of thing. You brought up a really good point there about percentage of people at best practice and what we have in our targets. So the industry BMP, so Smart Cane BMP, defines best practice for productivity. What we describe is what we have this word best practice, and we really shouldn't have it in there, and it will be gone soon. But what we're trying to describe is practices that are at lowest risk for water quality. So they're kind of two different things. So that's an issue with that current target. So we're talking about two different things there. So and that's where we've gone out and we've done some surveys with help of stakeholders in that region, and we think we've surveyed about 95% of the area in the Burdekin across all of our different stakeholders. So we have some pretty high confidence in the things that we measure in that region. So yeah, we're confident in what we're describing, and we absolutely know that it's different to the BMP program.
I think it would be a big mistake to uncouple productivity from best management practice, because it doesn't matter what you do if we can't grow the cane, we're all going to go broke. So productivity is important, and that has to have an important role in best management practice for nutrient runoff and everything else. So I think it would be a very grievous mistake to decouple that.
Oh yeah, absolutely. And 90% of the things that we're interested in do the same. They link, so the less the less losses you have, the more productive. So the less things that are running off your paddock, nutrient, pesticides, all that sort of stuff, they're staying in place and doing doing the job that you put them there for. So killing weeds or growing more cane. So we're talking about we are talking about similar things. It's just the level of which the implementation between the two programs is just slightly different. But as going forward, that 90% adoption of best practice, like, we shouldn't worry about that, because that's not something that it's a bad target. It doesn't give any direction, and you guys get beat over the head for all sorts of different things. Let's have a target that's actually something that's achievable. So if it's a nitrogen loss risk index or nitrogen use efficiency index, like that then opens up, rather than worrying about, oh, you guys need to reduce your rates, you reduce your rates. Let's talk about the things that you can do to lift the yields. So let's look at irrigation efficiency, or soil health, all these other things that we can do to lift the yields. So because you guys know that that guy there grows more than that guy. They're across the road from each other, very similar sort of soils. It all comes down to the farming practices on the two different places, sort of thing. So yeah, that's where we should be focusing on, is what are the things that we can do that make sure that more of the applied nutrient, pesticide, whatever, stays on the farm and does exactly what it needs to do.
Yes, well, I would argue that in the Burdekin Delta, and I'm not talking about Horton, and I'm not an expert on Horton, certainly in the Burdekin Delta, there is very, very, very minimal runoff. Irrigation runoff is nil. Large rain events, yes, you will get some runoff, and that will eventually find its way to the ocean, but certainly not through the Vatican River, because this is a problem that I've had with a lot of people when they come and talk about the Burdekin. None of the farms in the Burdekin Delta, none of the water runs into the Burdekin River. It all runs away, because the Burdekin River is the highest spot in the district, the banks of the river. So everything runs away from it.
Yeah.
So, and we are getting into, whether we like it or not, and I know you probably would agree that it's not the way we need to be. One size fits all. You can't look at what happens on one farm and then go across the neighbour or 3 farms down and see and say, well, they're doing it right, the other fellow's doing it wrong, because it certainly doesn't work like that. Some of the stuff that with nitrogen, when you talk about, it was interesting, to be A+ for applying nitrogen, you need to have variable rates throughout the block. Man, I need a couple $100,000 to set that up. Where's that coming from?
And that's why it's no longer there. It's not a sensible it wasn't a sensible thing to be measuring. That's why we don't ask it anymore. Like, that's the evolution over time. So
trouble is, that's an A. That's an A.
It's not
and
an
so
A.
The whole A,
it's
B,
not an
C.
A anymore. It's
Yeah,
not an A
yeah,
anymore. So it's changed. So we, you know, a lot of this, there hasn't been a huge amount of work in sugarcane on nitrogen stuff. Like if you jump over into wheat, corn, cotton, all that sort of stuff, there's been hundreds of years of work done on that sort of stuff. So sugarcane just doesn't have quite as much. So we bought some stuff from other industries in. So variable rate with inside a block, in grain growing areas is a really innovative practice. It's just not practical in cane and not sensible to do. And that's why it's not in the framework anymore.
Okay, thank you, Adam, and thank you, Phil. I think that was an interesting discussion. I could see people really paying attention to that, so thank you. Now, there are a couple of questions in the chat, but I'd just like to open it to the floor. I can see Michael's got his hand up and Dave as well. So, Michael, would you like to go first, and then we'll have a question from Dave?
Yeah, thanks very much, Renee. I just firstly start off and totally agree with Phil in terms of focusing on productivity. This whole contribution to the agriculture and the economy of Queensland cannot occur without agriculture and farming continuing to prosper. So it absolutely has to have a focus on productivity, just as an opening statement. Adam, some of the challenges associated with you know, having the one system fits all is quite significant. As Phil just pointed out, different regions have different issues in terms of runoff or different things. So that remains a huge challenge. But I did want to just focus on firstly just asking the question of what percentage of cane farmers would have been surveyed to arrive at the you know, the 6.3% increase in best management nutrient management for sugarcane, which was a great result. But of course, noting that like Weight Watchers programs, getting a consistent reduction in achievements is very, very difficult and be unlikely to keep that up consistently. So I'm interested in that aspect, but also I did want to, I'm quite excited about the fact that new targets might be established, and that follows on from an earlier question I had as to how often they'll be reviewed, to focus on things that can actually be achieved. I think is a great idea, and making them more practical and, as I said before, more realistic and achievable or attainable has to be the focus. Because when you look at the pesticides, for instance, the target is a 99% protection of, I think it's marine life. We've achieved 98.3%. And we get a B, and I just wonder how the hell do you actually get an A? If I had tried to achievement of around 99%, I got 98.3. I'd be certainly talking to the teacher about why I didn't get an A or an A plus for that. So I'll just start with those two. Thanks.
Yeah. Okay. So I'll just answer that last one. So that 98% score is about the loads detected in the waterway, and yeah, then you jump over to the practices was the other one. So the kind of there is some disconnect there at the moment, and that's part of the review sort of thing. So
sorry, Adam, the pesticides isn't loads based; it's based on concentration.
Oh, yeah, concentrations. Yeah, but it's
about the 99% is actually the Queensland Water Quality guideline for protecting high value ecosystems, which are Great Barrier Reef one. So that's why you don't get an A unless you actually meet the guideline, because otherwise you would be under the guideline and still getting an A. So the reason we do the cutoff at the 99 is because that's actually a legislated guideline. And then we recognise 98 is pretty good, so that's where the B comes in.
Okay, it's a very high standard.
Well, it's a legislative standard.
Yeah. So and the other one, I think you asked about how many people were surveyed to get that change. So what that change is based on is groups, NQ Dry Tropics, pharmacists, you know, the groups there that are doing work. They're funded by Reef money, so you know, money that's either from the federal or the Queensland government or Great Barrier Reef Foundation. So they've gone out on the farm, they've worked with the individual grower, changed whatever they've changed, and then they draw a polygon around the farm, so that, like I showed in the slide there, and then answer the management questions and come to us. So off the top of my head, I don't know how many hectares that was, and I've got the data, but you don't want to be watching me sit here and click through 10 files to try and find it. But you know, it was a significant area was done in the 2 or 3 programs that were run in that. So that data is in the report card, so you can actually get to that if you download the methods chapter for management practice, which we can put up and, you know, provide to Renee and Jade. They can send around to this group.
Yeah, that'd be appreciated, Adam. Just so that we get it, we know we know modelling is an issue. You also talked about averaging as an issue. It would be just good to know exactly what percentage of either landholders or land area that report card or performance, if you like, is based on, because I think many people believe it may or may not be representative of the greater proportion of landholders or land area.
Yeah. So that the change, the difference between, you know, the amount of change. So the stuff that the improvement is based on what's reported to us. So it's actual hectares and farms reported to us. So it's a bit of a, there's no mechanism really in place. We've been trying to get BMP in place, but there's been some issues there. But there's no mechanism in place to report annually voluntary improvement, and that's something we would love to be able to do. But we kind of need to know where these improvements happen. So without people telling us, we just cannot include it. Like we just don't. You don't know what you don't know. So, and we don't know. So we'd love to have something that we can report, you know, voluntary change. Like I think that's a massive thing that's missing from the program. And you know, it's a couple of day workshop probably. So we're not going to solve it today, but it's, you know, it's something that we need to address down in the future.
Just on the BMP data, Adam, we just wanted to clarify, we can actually take that data, but we need people to opt in to the reporting of that.
Yeah. And that's probably been the biggest issue, is there's just not enough hectares opting into the reporting. So
if I can just jump in, sorry, it's just a quick time check. We are at lunch, so I am conscious that Dave had a question. I think we've probably got time for Dave's question very quickly. Brock, I can see you've got your hand up. Can I invite you to put your question in the chat box, please? Because there's a couple of others there that Adam will be able to answer, perhaps over lunch, Adam. But if we could just quickly maybe go to Dave's question, and then we'll break for lunch. Okay, thank you. Yeah, go ahead, Dave. Yeah, I think you're on mute, mate. You might have to take yourself off mute.
Okay, we'll try again. Okay, my question was, how is the water use efficiency targets going to be determined for future reports to follow the nutrient loss matrix? And where do you plan to get this information from?
The target. So what we've been doing is working with CSIRO and heaps of, they've got a whole heap of response curves for trials. So, you know, you put on different rates of fertilizer and you get different responses to that. So they've been looking at that and going, okay, well, and I'm not the researcher in this. I don't know exactly. So basically using that data to go, okay, well, this is probably the best you're ever going to do. And this is probably the worst you're ever going to do on given rates and given yields, sort of thing. And then trying to link that back to a ratio between rate and yield. So we're working with those guys. Hopefully we'll have a paper that we can put out, you know, talking to the SRA guys and you know, as many people as we can, sort of thing, to get some consensus on that there.
Yeah, right. So I agree with Phil and Michael too about productivity. You've got to, you know, it really affects all of us, and it's going to take a bit of sorting out, I think.
Yeah, absolutely. And that's why we think like a nitrogen loss index is better, because, you know, we're not trying to say drop your rate. What we're trying to say is try to limit the amount of nitrogen that is lost. So if we can remove some constraints to yield, like, you know, that means that extension programs can then work on things that are constraining yield. So whatever it is, soil health, weed pressure, whatever it is that constraining yield. So if you guys are growing more cane with the same inputs, water quality improves, the industry's sustainability and productivity over time improves. So, you know, that's a win for everybody if you guys are growing more cane with the same inputs. So.
Okay.
All right. That's great. Thanks, guys. I think there was a lot of interest in that conversation. That's excellent. Hello, everyone. Welcome back. Hope we've all had a good lunch break. I know it was a quick one, but I hope we've all managed to stretch our legs and refresh our brains a bit. So we now have Mark. Hello, Mark. I can actually locate you in my Brady Bunch layout here. How are you going?
I'm going well. You'll have to help me getting my talk shared. It's open.
No worries, mate. So if you go down to the bottom where it says share screen, can you see that?
Yep.
And if you click on that, it should give you a new window, and there'll be your PowerPoint should be there, and you can just click on that and say share. That's it. It's looking good. Okay. No, here it is. Well done, Mark. Victory is yours. Okay. All right. So feel free to kick off whenever you're ready. Now, would you like to share your video, or are you going to do it with video off?
Can you see my screen?
We can see your screen, yes. We just can't see you.
Oh, and you can hear me. That's all you need. So, yeah, I'm Mark Silburn from Department of Resources. Mel Shaw will also be on. She's not presenting because she's got a couple of kids at home today, so she wasn't sure that she could get the time between kids. So I'm going to talk about the paddock to reef modelling. This is the paddock scale modelling, and we'll focus on the Burdekin sugarcane side of it. I'll talk about agricultural models, you know, broadly how they work, and then how we validate them. And I noticed some of the chat was about what data sets get used, and we try and use as many field measured data sets as possible. I'll talk about the actual modelling program and how modelling has changed over time, and the links to management practice adoption questions and to the projector. And then I'll give some specifics about the Burdekin sugarcane modelling, including results, and then a little bit about the future. So for sugarcane, we use APSIM, and it's the reason we chose APSIM is a long history of within the Australian sugarcane industry. So how these models work is they basically consist of a lot of equations in neat modules. So one that grows a crop, you know, one that does the water balance, and you know, all the sort of things that happen in the field. So the equations that are used.
Sorry to interrupt your flow. Are you able to put your PowerPoint into full presentation mode? You know how to do that? Like it just makes it bigger, and then everyone can see it better. Yes, that's great. It's just going to take a while for it to load. It should be good. Okay, sorry. Yeah, please keep going. I think it'll load eventually. Thank you.
Yeah, so the equations and, you know, what's in the model was developed from field measurements and from fundamental laws, like the models maintain mass balances. So there's a soil water mass balance, soil carbon and nitrogen balances, crop residue balances. Basically, APSIM's a one-dimensional water balance. That means vertically, averaged over an area that could be considered uniform soil, climate, management, and crop. Each day, rainfall and irrigation happen. It goes either into changing the soil water store or into soil evaporation, crop transpiration, and sometimes runoff and deep drainage. So deep drainage is water loss below the root zone of the crop. You can see the picture of it there. And when rainfall and irrigation happen, they, after runoff is removed, the water is routed down through a series of layers in the soil model. As you can see in the slide, the inputs include climate data, soil information. So there's things like a runoff parameter that tell that one soil runs off more than another. There's water holding capacity. There are crop parameters that are used to grow the crop. And there's a lot of management. Just trying to locate the forward button.
Mark, what we might do, I'm sorry to interrupt your flow, what we might do is actually, if you can just stop sharing your screen and we might restart, because that might help us see your slides a little bit better. Sorry. So if you can go down the bottom, there should be a button that says stop share, or actually it's probably up the top. Should be something red with a stop button that says stop share.
I'm not seeing the presentation screen anymore.
Okay.
Sorry, the meeting screen.
You're not seeing them. What can you see? Your slides?
I've got 3 images of my talk.
Yeah, just go to the go to the next one. Is it working? Can you advance your slides?
So I have actually hit the presentation mode button, but
that's all right. I think it might have opened in another window. It probably thinks it's opened in another window, so it's somewhere else. But that's okay. Are you still able to advance your slides? Is that working for you? Oh yeah, I can see where you are now.
Okay. So I hope I've described the model. I feel like I might not have, but I guess the main thing is about these models, they were developed over a long period of time and a lot of field trials have gone into them. And as a way of explaining that, a scientist would say, well, you know, once you've done a study like that, you need to publish it. So that graph is a track of all the publications in each year about APSIM. There are 54 APSIM papers about sugarcane, and there are 107 APSIM papers about soil. And each of those papers would represent a, you know, a large study where someone has taken data sets from the field and they've tested the model against that data, and they've come up with new equations and they've put them in the model. So the models keep growing and improving over time. So while we're working on model validation, we're actually 5 ways we can validate the model. So validation means, you know, proving that the model is valid and that it mimics, you know, things we see in the real world. So the first thing we can do is validate the inputs. So there's a series of the inputs that we use. Oops. So we're really saying, let's go out in the field and measure soil parameters the model needs. Let's make sure we've got plants that grow at the right rate, management practices that technical working groups tell us about, and therefore that adds to the confidence in the modelling. We can also validate against individual processes. So the graph is the amount of nitrogen mineralisation in the soil. The DES team published this work, and you can see the...
Mark,
Yeah.
Okay. Sorry, we actually can't see your slides advancing. I'm really sorry to do this to you, but we might have to stop your talk. And can I just ask you to, we'll just spend a little bit of time finding that stop share. Yeah, oh, actually, Jade's just telling me that if you hover over your PowerPoint icon down the bottom, you know, when you hover over your little PowerPoint icon, that's it, and you can see 3 different windows. One of these must be the one that you can see. No? Okay, can you try clicking on another one? So that's it. And try clicking on try clicking maybe the one on in the middle. I think it might be the one in the middle that you need to click on. That's it. No?
So you're seeing the right one now?
No. I think we might have to ask you to stop sharing the screen. Hopefully you can find that option.
Okay, now.
It's all good. Can you see, if you go to the very top of your screen, can you see something that says you are screen sharing, and there should be like something that says stop share?
Yep, stop.
That's it. Beautiful. Okay. Now, if you can go again to the presentation that you're in, and then go down the bottom where it says share screen, and we'll just try it again.
I'll move the talk that I'm trying to show you if it'll let me. It's not letting me.
Okay. So the talk that you're trying to show us, if does that appear, like if you click share screen down the bottom right now, you know how there's like a window that comes up with all the different windows that you've got open? Can you see the presentation that you're talking to?
Yeah, it won't let me move it onto the screen you're looking at. That's the problem.
Okay. Yeah. Yeah. Okay. So can you tell me, Mark, when you click on share screen, it'll come up with lots of different windows in front of you. Is that correct?
Yeah.
Yeah. Okay. Can you see, is one of those windows the talk that you want to share with us?
Yeah.
Okay. So if you just click on that and then go, I think it's called start share or something down the bottom. I think it's yeah, see, if you click on whatever screen it is you want to show us and then hit the blue share button. Is that working for you? No, here it is. Looking promising.
Is that better?
That's it. Victory is now yours.
Okay.
Thank you, Mark.
Good.
Thanks for your patience. Sorry, thank you. Go ahead. Cheers.
Okay, so we can validate the model in terms of individual processes. This example is the rate of nitrogen mineralization in the soil. The paper actually had a number of different soils they tested this on, and the yellow line is the model after it's been calibrated to that data. So that gives us the different soils, another set of parameters or equations that help the model work. Now, one of the main ways that we validate the model is using these field trials. This is a trial run by CSIRO in the Burdekin. They had 3 field sites where they monitored sugarcane nitrogen losses in runoff and leaching over time. That's the ability of the model to model the sugarcane yield. And that's the top is the cumulative runoff. The red line is what the model said, and I believe the dotted line is the field data. And the middle one is nitrogen concentration in runoff. and the bottom is the cumulative N in runoff. So the top one is the actual amount of water running off. So by doing that, we learn how to make the model mimic the field behaviour. This is, we're very keen that the model can model the effects of management practices correctly. So this is some new work we did on a mill mud trial, and the treatments on the y-axis are different amounts of mill mud versus mineral fertiliser, and you can see measured and simulated, which is the distance across the x-axis, are reasonably close. So that was new to us because we hadn't previously modelled mill mud very much. Once we've done a series of modelling, like what we call scenarios, so we end up with many simulations, we can benchmark using a whole series of different methods. Burdekin collected all that data for pastures in Australia on the nitrogen leaching through the soil, and the bars are our moderate risk, high risk scenarios, and you can see they span Burdekin's data. So there's a whole series of different benchmarking tools we can use. We can look at what yield per unit of water use we're getting. We know things about what the typical fallow evaporation should be and what sort of percentages of runoff we should get. So there's all sorts of benchmarking tests we can do. So we're very keen, before we use the models, to do all these different types of testing so that we've got confidence in what the model does. So it goes right back to all the equations that get built out of field studies, and then testing at the end once we've done a live set of scenarios. This is about how the paddock modelling goes into the catchment model. So the catchment models are what are used for the report cards that Carl's told you about. So a whole series of different paddock models get run, as shown on the left. All the paddock models for sugarcane then get, or the results get put into the catchment model where there's sugarcane. Now, the reason we do this is that the catchment models are actually they don't really have ways of modelling on-farm behaviour, whereas the paddock models do. So we merge how much management adoption the management adoption team report to us with, so we have a simulation of each of those levels of management, and for sugarcane, those go into those parts of the catchment. And we can then report, as shown on the right-hand end, the load reductions, that's the cumulative reductions in sediment and DIN over the whole period of the paddock to reef program. I'm not actually seeing the slides I thought I'd see. But the one thing the catchment model does that makes it a useful contribution is that it adds in all the loads from all the other industries. So you've got the sugarcane coming out of the APSIM model, but you've got grazing coming out of other methods. You've got, in some catchments, bananas coming out of other models. So that way there's an equitable amount of information coming in. So in the Burdekin, a lot of the sediment would be coming from that vast amount of grazing land and not necessarily from sugarcane. So this is the water quality risk framework that comes into the management of practice adoption, and you can see that it's got a reasonable level of detail about this is soil management or sediment management, and you've got low risk, which is green cane, trash blanket retained. There's controlled traffic, land management during the fallow. So as you go across to the right, you've got things that are considered a high risk scenario. So the management practices adoption team break it down to that level of detail. For us to model it, we actually needed a lot more detail. So they had one of them for nutrients, for pesticides, for recycling pits, and for mill mud. So what we do with that is we take it to an expert panel, of which quite a few are probably in the meeting, and they break that sort of fairly high level practice framework down into the exact details. So, you know, planting happens at a certain time. In the fallow, there are certain tillage practices. There's certain nitrogen applications, and we need that broken down to the exact day, the depth of the tillage, the amount of the nitrogen. All those sort of details have to go into it. And we've done testing that management practices, and we have this monitoring data down on the bottom left of the screen, where we're showing that we can model the effect of tillage. So the experts tell us about how much tillage happens. We know the model can mimic the effect, in this case on soil erosion, of those tillage practices, and then we run the scenarios. So this is reiterating. So we consult local experts in sugarcane farming, and they define typical scenarios. So, you know, for each of the levels of risk, there's a different scenario, and for sediment, nutrients, etc., there's a different scenario. There's a list of the people that have helped us in the past, and this is ongoing. You know, I think the next slide says it. So we typically attempt to set up what we think the practices look like, the scenarios. We take it to the expert panel. They go, oh no, that bit's wrong. We'll change that. We run the models. We take that back to the expert panel, and they then go, oh, that's looking good, but we could improve this one over here. And this has been through a whole series of iterations over the years. For instance, in 2016, we introduced dissolved inorganic nitrogen runoff model that was based on measured data in the Burdekin. And coming up in the middle of this year is a 5-year review where we'll go through all this again and come and bother you again. So Adam's 20 questions, you know, they fuel the water quality risk framework. We break that down into very detailed practices. It's actually the management practice adoption team that then assign which of the management practices there that are being implemented in the field to our model runs. We don't actually see the detail of their data. They provide the models with a code that describes practices for a project. So the before practice might have been C for sediment, and the after practice might be B for sediment. And the projector is a tool that basically gets all the model results, and the management practice adoption team and regional bodies can use the projector to really look at what benefits will accrue in terms of water quality outcomes. So there's actually very few people who know, you know, outside of Adam's team, that know much about, you know, the details, but we're given enough information that we can answer the question, what is the water quality outcome of that change? So I'm just getting into some of the details of modelling in the Burdekin. So we obviously have a soils map, and broadly speaking, in the Delta, you've got well-drained soils, and in the Briar around Clare, you've got heavy vertisols, sodasols, etc. Now, in the future, we hope to expand the range of those soils and get it a little bit better. Generally, in the heavy vertisols, the water balance is dominated by runoff and a lesser amount of drainage. And you can, in the delta soils, the structured dermasols or loams, it's much more dominated by drainage. Now, this example is actually for a high-risk irrigation scenario, so high water inefficiencies, and as I'll show you later, things can get better with better management. So those two examples were just two of the things that go into the scenario. So all the simulations we do are a combination of 6 soils, 5 climates, 7 soil managements, going right around that half circle, including 4 mill mud managements, 4 recycling pits. So all up, that adds up to a mind-numbingly large number of simulations. I'll just show you a little bit more of the detail. In any cane field that we model, we actually model multiple start years. So that means at any one time, part of the, let's call it a farm or part of a farm, part of it is in a fallow, and in the next simulation, another part is in a fallow. So you can see we've got plant, all the returns and fallow happening at any one time. So that means that, if something happens like sediment generation in a fallow, it's diluted by all the runoff from all of the plant and return crops. We've expanded the number of planting dates to 5 through the year, and that also dilutes anything that comes out of any one simulation. And the expert panel would allocate these percentages that are under those planting date scenarios. So we now have 5 planting dates in each of the districts to better represent management. So as I said earlier, we built DIN runoff models from Burdekin data, and we always find relationships between the nitrogen applied and the DIN in runoff. What we did here was we separated the events with rainfall runoff and the irrigation runoff. Rainfall runoff is driven by the nitrogen applied and cumulative rain since application or time, whereas the irrigation losses are driven really by because they're happening a lot, so we've really just got a constant background of those irrigation losses. That's the model for the DIN in, or nitrate, it says, in rainfall losses. So we're using Burdekin data to mimic the nitrogen runoff in the Burdekin. So when we get to soil and sediment management, once again, we've got from low to high risk, we've got management for the trash, the fallow, traffic, and again, we get information from the expert panels to come up with the details for all of those things. So getting way down into the detail of the many, so you can see the low risk has 0 tillage. The fallow has soybeans that are harvested, not buried, so they maintain cover. Here's some of the results. That's this is the nitrogen rate that we apply. So again, our expert panels advise us that, in fact, nitrogen use efficiency is used. So we use the yield potential and a nitrogen use efficiency of 1.2 for A and 2 for high risk. So that data there, called survey, is a survey of, I think it was 100 odd growers and what they're applying, and you can see that that's in the upper to middle range of the N rates that we're modelling. 108 respondents in the survey. I'm just moving on to mill mud. Nice big tractor. And these are the tonnes of mill mud applied, and in the bottom panel is the nutrient analysis of those. So those come from experts in the mineral compositions. While we know it's highly variable coming out of the mill, we have to use something, and we've used data that was published. In terms of irrigation applications, we also use sort of a benchmark of how much cane you'll grow per megalitre per hectare, and essentially at low risk you have high efficiency, and at high risk you have low efficiency. And the little panel there will please Steve Adhard, because that's auto irrigation, which is probably doing as very good practice and very low application. And it includes automation of things like turning the irrigation off when the farmer doesn't want to get out of bed and go and turn it off. That's what I'm told about it. And I'm sure Steve will talk about it, tell you all about it. Recycling pits were mapped and either published mapping or local input. The little dots are where we think there are recycling pits. And then an analysis was done that Mel could tell you about to work out the catchment contributing to each of the recycling pits. And then this just shows the distribution of them. And it seems, you know, that these are for the different mills, and there's a broad distribution of use of recycling pits, probably for good reason. Just go back and check we got all that. Yeah, so below risk, we actually allocate 100% of the irrigation tailwater is recycled, and 10% of the rainfall irrigation is also captured. And then as you go down to high risk, you know, those things reduce and you end up with nothing being captured for the high risk. Some results. This is erosion for, it's summed up to a farm. So, you know, there's various planting dates and start years and everything have been added together. And it's it's some sort of typical farm in the Don and in the Horton. And you can see that there are differences in the responsiveness. So as you move through soil management, the Don is slightly more responsive to those management practices in terms of controlling erosion. So the Don is largely a delta situation, and the Briar is the Horton is Briar. But you know, those relativities could change. You know, if the slopes would be different in those two farms, and it's just illustrating that there are differences due to local information. This is the DIN runoff model losses. Sorry, I'm not actually sure if it's DIN. Yep, it says annual runoff, okay. And it's unfortunate about these plots that they really don't need those top error bar. But essentially, again, the more mill mud you apply, the more sorry, that's drainage and runoff. Got it worked out. And you can see drainage is the big component compared to runoff, but that varies between catchments as well. So this would be the Briar, and that'd be, sorry, that'd be the Delta, and this is the Briar. So this is showing the interaction of fertiliser management across the risk framework and irrigation management. And I think this is quite interesting because I'll just see if this happens here. You only have to move from high risk fertiliser management to the next, like a medium high risk, and irrigation management between the top two categories, and you've actually got a huge reduction in the DIN drainage. And I think there's a real win-win there if growers can start, adopting those practices and really changing quite a lot. And of course, once you go down to the really low risk practices, you're getting very little DIN drainage at all. So kind of coming to the end, in future work, we're undergoing a program review coming up in the middle of this year. We would review the sugarcane management scenarios again with the expert panels. We would look into modelling enhanced efficiency fertiliser and controlled release, and APSIM has some modules for looking at that. We'd look into the imidacloprid application for cane grubs and look at how that can be managed. And we think we can improve recycling pits, whether it's in mapping where they are or how they behave. So they're just some examples of things that we would try to improve in the future. We're very interested in getting monitoring data. We gather there's a lot of work proposed in the Burdekin region for that sort of monitoring. It says there that runoff concentrations can be used for sensibility testing only. And I think the point of that is if you're running a runoff trial, we need to know quite a lot of things about it. We need to know the soil it's on. There's a picture there of the water holding capacity of a soil. So we need that kind of information to run the model against that field trial. We generally have resources to support that soil characterisation and laboratory analysis. And in some regions, we've actually been measuring soil water holding capacity profiles on other people's trials so that we can improve the models. So to be able to model a site, we need to have a complete picture of the site, the soil, the climate, the management, and some replication would be ideal so that you can overcome natural variability. So, do approach us if you are running a monitoring trial, and we may well be able to help you in designing it and certainly in analysing it. So to summarise, these types of models we used have been developed and tested and improved over many years using monitoring data. The paddock to reef models have been calibrated using as many Burdekin field trials as possible, and the results are generally consistent with available field studies, but there's always more to do. So we've only just got mill mud going. And we're very keen to collaborate. And there's a picture of me as a young man doing field work. It actually says on the bottom modeler doing field work. So there you go.
That's great. I love the picture. Thank you, Mark. That's excellent. Thanks for stepping into at the last minute for Mel. It's always tricky doing these things, so thank you. And I apologise, I've just seen your message that you sent at lunch asking if we could practice sharing your screen. So I apologise, I missed that one. But good on you. Thanks very much. Now, we do have a couple of questions I can see sitting in the chat box, but before we go to those questions, does anyone have any sort of verbal questions that they'd like to ask Mark? If I could get you to stick your hand up or make yourself known. Okay, I can see Greg, you've got your hand up there.
Yeah, thank you. Mark, you can calculate or model how much DIN is leaving the farm. How do you actually validate or calculate the volume and flow rate of DIN in waterways that then ends up into the marine environment? How does that actually work, please?
It's literally into the catchment modelling problem. Basically, the catchment model.
I can't hear you, sorry.
Why would that be? I'm talking.
Yep.
Can you hear me?
Yes.
Yeah,
okay.
So I think maybe we just had a bit of a slow internet moment, sorry.
Yeah, so yeah, it's a catchment modelling question, and the catchment break the catchment up into 30 square kilometre subcatchments. They have streams in them. They are calibrated to all the gauges in the reef catchments, and obviously there are ungauged areas, and they have to allocate those parameters from a neighbouring catchment that has like properties. So the surface water gets moved, and it's responding to rainfall. So when the catchment models are getting big rainfall, so are the paddock models. So there's compatibility there, and they route or carry, the DIN in surface water, and they would be able to allocate, removal and breakdown of the DIN as it went along the river system. But importantly, they also take all that deep drainage water and move it through the underground and bring it out into the river. Now, the key thing is that they have all the gauged loads measured by Catherine's team, the DES team, and so they can calibrate what they get coming out of the end of the model to all that monitoring data. And so if there was some sort of losses or something of the DIN, they can calibrate to get that right. Does that answer your question?
Does that answer your question, Greg?
I wouldn't mind seeing some information just being sent through to me, please, if that's possible, just so I can consider it further. Because it sounds fairly complex, and we're being judged as an industry in terms of what goes out into the marine environment, and I guess we just want to get some more confidence around how that actually works.
So, Renee, can you pass on his contact details, and I'll
Yes. Certainly can. That's all right. Now I can see Terry's got his hand up, and then Michael. Terry, would you like to go ahead and ask a question? Yeah. You might be on mute, I think, Terry. You want to go down to the bottom left and just hit the microphone button. No, still can't hear you, mate. If you go down to the bottom left, there's a picture that's of a microphone that says mute. And if you click that, it should work. This is Terry. Actually, can we unmute Terry? Sorry, Terry, we're just going to see if we can unmute you from our end so we can sort it out from our end. Terry Williams? Yeah, Terry Williams. Can you unmute him? No. Okay. Terry, can you see down the bottom left hand of your screen? Hey, there we are. You're ready and raring to go.
Okay, just two questions. All right. What was the date when all those recycle pits in the Inkerman area? Have you have a date on them? Because there has.
I'd have to dig that up. I mean, I know it was about 4 or 5 years ago, and MQ Dry Tropics sent a lot of people out. Well, there was a certain amount of field work and mapping and looking at imagery. And in the next round, we would be looking at updating that and making sure we capture any.
Mark, so sorry, I think your internet might be a bit slow and you're breaking up a little bit. Could I ask you to start that answer again, please? Sorry.
Okay, I'm not sure much I can do about it, but no, basically,
that's better. That's better. Thank you.
We would it would have come from several years ago, the old work, and in the review process, we will be updating that, and seeing whether there are new recycling pits or ones we missed last time.
Yeah, there is one new one that's gone in, a fairly large one, probably about 20,000, about 20 megs. But Leichhardt Lagoon on Cassidy Creek, that has been used as a recycle hole also. So no water runs past it. That any water that runs of any other farm runs into Cassidy Creek, it's relifted out of the Leichhardt Lagoon. So we can classify that as a recycle hole also.
Yeah, well, we might come looking for you to tell us about that local knowledge, because that's very helpful to us.
Yeah, that probably holds about 20 to 30 megs also. So.
Okay, thank you, Terry. Michael, question?
Yes, thanks, Renee. Again, I just probably echo Greg's question and comments in relation to not feeling wonderfully confident about how it actually, the correlation between what comes off the farm, what goes down the creek and what goes out to the reef. And I guess that's what I'm really, really interested in. I've got a 20-year background in auditing, and I guess my natural sense is I'd like to see the data about how that actually correlates. We know that each individual bit of DIN and sediment and pesticide is not microchipped to actually see where it goes. That would be ideal, of course, if we could put a coloured dye on them or microchip them and follow them all the way out to the reef. That would give us all a greater assurance that the modelling is correct. But in the absence of being able to do that, it would be good to get a better understanding of real numbers in terms of how it actually correlates down the river. We already know, for instance, that in terms of how you measure the concentration in a river is a bit like my swimming pool. Depends on whether you've just put chlorine in there and where you measure it, whether you measure it on the outtake, the intake, or somewhere in a quiet corner. You can obviously get completely different results. I know there's a lot of variability there, and we're not asking for absolutely exact science, but we do look for some measure of confidence in both, obviously, the target setting based on past measurements and, current measurements. We'd really appreciate being able to have an understanding of it and be able to see it all the way through, rather than, of course, just relying on people who provide data up the line. So happy for my contact details to be provided along with Greg's as well.
Jade and Renee, in other regions, we've offered a deep dive on the modelling because it is such a complex issue. So we could offer that again in this region. We'd have to work out when and who, but that's definitely an offer that we can make.
Thanks, Carl.
That's great. Thanks, Carl. We've made a note of that here, so that's excellent. Good questions. Thanks, guys.
I think the loads monitoring team could also offer you some information about when they've tested that sort of swimming pool variability, because it really depends if it's well mixed, and they try to find a site that was, and there have been studies in the past that look at whether sampling at 1 metre or wherever is giving you the right answer. So it's a very good question.
Great, thank you, Mark. Now, I know Michael's also put some questions in the chat, but I can see a question in the chat box here from Brian. And Brian's comment is just wondering how relevant those soils maps are at predicting how soils are actually behaving, given that there's been a large amount of earthworks and soil ameliorants added. Did you have any comments on that?
Yeah. At the moment,
Mark, we're having trouble hearing you again. You might need to flick your microphone or whatever you did last time.
I think I just yelled.
There you go. Yelling is good.
Okay, maybe it takes a little bit of time to learn I'm talking. Yeah, so it's a good question. And across all the cane regions, we're actually doing new mapping. I can't guarantee when or how that's going to happen in the Burdekin. And certainly the ameliorants will have changed the soils in the Burdekin quite a bit, and people moving and digging them around. So, if we knew that large amounts of those things had happened, we would attempt to send the soil surveyors in and do some new measurements. And I'll kind of add that to the list of questions I've got for the soil surveyors.
Okay, great, thank you. And Michael's also asked the degrading. is that to do with nutrient management? Oh, sorry, Michael, maybe I should ask you to ask these questions. You're here and you've got them in the chat. Would you just like to ask your questions that you had in the chat, please, about the D grade for nutrient management? And then you had some other questions about nutrient application and the existence of recycling pits affecting irrigation assessment.
Yeah, thanks very much, Renee. No, I was just looking at one of Mark's slide, which had a D grading against nutrient management. And I just sort of thought that the most recent 2021 report card score was a B, but maybe I was mixing up regions or areas. So that was probably more of a comment. And then the subsequent two comments I had, I think I was just simply following Mark's slide, looking at the risk assessment of nutrient application. And I was noting that surely that would be affected by things like wet weather events and timing issues and then irrigation practices. And then I think the next slide was irrigation practices. So that answered that. And then I was making the comment about surely an assessment of irrigation flies directly affected by the existence of a recycling pit. And then Mark's next slide was about recycling pits. So I was, apologies for that. I was probably just ahead of the game and not knowing what slides were coming up next.
Yeah, yeah. Well, it sort of shows we've headed in the right direction. I don't think I specifically said anything about the Burdekin being in any one category. We model all the categories and then we take the management practice adoption data and that gets merged into the report card. So we don't really have a lot of say, you know, it just comes out, management practice adoption levels, and then we model all the scenarios and then they get kind of added together.
Okay, thank you, Mark. Do we have any final questions for Mark? Nope, I can't hear anything and I can't see anything.
I'm about to go, and it's for Mark, and this is I've raised it before with other presenters here, but I think you're making some big assumptions on adoption practices. And if you're going to have a model, you've got to have good information in, and I think you've got to have a real handle on just how well people have adopted new practices over time. I don't know where you're getting the information from, but it seems to me a lot of the information you're getting about adoption practices is not up to date, shall we say.
Well, it's really up to management practice adoption, that question. I believe they do surveys of growers. They get information from growers who are being who are undertaking investments, but there would be a lot of growers that's not included. And I know there was discussion about that earlier with Adam. It's not really my province. I just hope they're giving us good information.
Adam actually has his hand up, so I think you'd probably like to make a comment there, Adam.
Yeah, I guess like with the review of the targets right now, it's really important we get those adoptions right. So we'd love to collaborate with anybody and everybody here about getting those right. So like, yeah, anything that you can give us, anything that anybody can give us about adoption of practices, we will take it and add it to our, you know, put it in the mix of the things we use to come up with the next benchmark.
Thank you, Adam. And Brock, did you have a contribution?
Yeah, I was just going to comment on same sort of thing as what Adam was saying, because I'm one of those people too, like a couple of others on the forum today, that you know, when we're in the field, that's part of our deliverables for projects, because we've got to ask those questions. But I'm sure you've been in the situation, Phil, where you've had to answer those questions, you know, many, many times in the same year. And, you know, I can appreciate it's a pain in the bum because you've got to go through and tell, you know, all these different people the same sort of thing. And also,
yeah, I can tell you that's the problem. I think in my 30 years of farming, I've been asked once what I do, what I actually do on farm. And it was a survey that was sent out And I thought some of the questions were pretty stupid. Like one of them, and this is going back a few years, they asked me if I bury my fertiliser. Well, shit, they've been doing that forever. You know, I don't even know why that question was there. But anyway, that's the sort of thing that frustrates me a lot. I cannot think of any grower that I know that has been asked. This is growers that have not applied for money from the government, have been asked what their practices are.
Yeah, and that's the thing. A lot of these are tied to, programs that are water quality related. So if you're a farmer that hasn't engaged in that before, or you're not interested in it, and there's many that don't, which is fair enough, it's your choice, but you're unlikely to get asked those questions. And, it is a lot of questions, and it's, probing about stuff about your farm, and some people just simply don't want to answer those questions, and we can't force you to do it. It's not legislated or anything like that. So yeah, you're right. The data is reflective on what information is being collected and the people who we survey. And, things can change on a dime too. Like you might answer the question about pesticide that, you're only using knockdowns, and then, La Nina gets announced and you think, well, I better put down a few residuals or something to, control the weeds, because I'm probably not going to get on it, once it starts raining. And, your answer can change within the space of, a month. So yeah, there's things like that that make it challenging. But I mean, if there's more people like you willing to put their hand up to, get asked those questions, I'm sure there'll be someone who'll want to go out and do it.
That's great. Thank you, Brock. And yeah, definitely been a common theme today, Phil. So thanks for that. Okay. So Arlen and our next speakers, I'll just let everyone have a few moments just to type their questions into Mentimeter, so you guys can sit back and chill out just for a couple of minutes, and then we'll move to your presentation. Okay. Well, feel free to kick off whenever you're ready, Arlen.
Hang on, I'm just having for some reason I'm having a technical problem at this side. Is that advanced all right?
Yeah, yes, I think it did. Yes, it is. Yep.
Okay.
Thank you.
So I've just, I've got Russ with me here. And he's just going to do a quick introduction to the project, and then we'll go through the presentation.
That's provided I'm in presentation mode. Yeah, as you realise, we're doing a joint presentation. I'm just going to do a quick overview of how and why Briar Irrigators got involved in water quality projects, and what we consider to be the key finding from this project that's been funded by the GBRF. And then Arlen will provide you with a bit more detail of the actual project itself. Briar Irrigators have been keenly interested in water quality for the last 7 or 8 years. We used to receive exceeding notices from the Department of Environment and Science from the Burdekin Creek monitoring station. And at that point, we realised that if we were going to defend our present farming practices, wanting to debate the issue at all with any credibility, we needed to have some science or facts in the form of data on our side, so that we actually knew what we were talking about. And initially, we had a small project that was funded by the Department of Agriculture and Fisheries, where we did sub-catchment monitoring. Got out of the Burdekin Creek into the sub-catchments and did 4 monitoring trials there. And while they were broadly consistent with the results that were being provided by DES, there was some significant variations between the 4 different sites. And it was then a natural progression, I think, the irrigators involved wanted to know why there was this variation. Was something different being done on the farms that are providing the irrigation runoff to one monitoring site compared to the others? We were fortunate enough to be funded by the Great Barrier Reef Foundation to conduct 8 trials on farm. And those trials were aimed at seeing what practices on farm actually resulted in a reduction in irrigation runoff of pesticides and kept nutrient in that irrigation runoff. And I think the key finding, in our opinion anyway, even though there's several findings, is that the bulk of our nutrient and pesticide runoff occurs in the first 4 irrigations. And that's somewhat at odds of what we were being told previously. We were being told that no matter how carefully we manage the irrigation runoff, that the bulk of our losses occurred when we had a significant rainfall event. And as you'll see in the slides and the bar graphs that Owen will present in a minute, that's not the case. Both chemical and nutrient runoff occurs mainly in the first 4 irrigations, and unless you're unfortunate enough to get an unseasonal rainfall event before those irrigations occur, by the time we get a rainfall event, yes, there is a small spike, but as a percentage of the runoff that occurs in irrigation, the concentrations, it's quite small. And again, we're fortunate in the Burdekin to be in the dry tropics. It's very aptly named the dry tropics because although it has been known to occur, most seasons we get very little significant rainfall in that crushing period, and that's when most of the fertiliser and chemical is applied. To the extent that we get a rainfall event, which is normal around Christmas time, even the later ratoons have had their fertiliser and chemical applied and probably had 3 or 4 irrigations before that event. So just in closing, before I hand over to Arwen, what we're really looking for is more recognition of that in the paddock to reef evaluations and questions. Hasn't necessarily got to be recycling pits that contain the irrigation runoff. In some situations where recycling pits aren't practical to install for whatever reason, automated irrigation greatly reduces the amount of runoff, and even very diligent and efficient irrigation can do it. But the key to it is if you can contain those first 4 irrigations on farm by whatever means, you're greatly reducing your contribution to nutrient and chemical concentrations in the waterways. Okay, I'll hand over to Owen.
Thanks, Russ. All right, so I've just advanced the slide. Has that worked all right? Yep. All right, so yeah, just to give a little bit more detail from carrying on from what Russ had said, what the project was about was monitoring pesticide and nutrients in irrigation and rainfall surface runoff. So I just need to make the point there that we did not measure deep drainage losses. We did not measure denitrification, things like that, just surface runoff. There were 8 paddock scale trials of farmer-driven practices over 2 years. So it was the growers themselves that dictated what trial they wanted to do. Agronomy support was provided by Pharmacist and BPS. They both had 4 trials each. So a big thank you to Sherry from BPS and Evan from Pharmacist, who basically designed and implemented the trials and also put together the productivity or harvest data at the end of those, which we don't have time to present today. It was quite intensive water quality monitoring, so we had more than 1,200 water samples collected and sent to labs. Just a couple of things to remember when we're looking at the results. As Mark Silburn alluded to, there's many external influences on water quality. So there's a lot of inherent variability in the results that you'll see. Not all of these can be identified or controlled, much as we try to. Field experiments can therefore yield variable results. And because of this, we try to implement multiple replicates to reduce the noise in the data. Statistical significance testing has not been conducted on these water quality results to date. So that's just something to note as well. Now, can you see my mouse circling over the graph there?
Oh, yes, I can. Yeah, if you go slow, yes, we can see it. Yeah, thanks.
Yep. Yep. So this is just a note about interpreting the results. We've got a bunch of graphs that we'll be putting up. What we did is we monitored generally up to 12 runoff events, surface runoff events for each site over 2 years. So we generally would do around about 8 irrigation events and then the first 3 or 4 rainfall events, and it really depended on the season. So what you'll see across the bottom, each of those events and associated date. Now, because we had multiple replicates in each of these sites, when you look at the data here, oops, the bar graphs are basically the average of each of the replicates, and we've put in the maximum and minimum values there as well, just so that you can see the range of values that you get. And that really relates back to that inherent variability that I was talking about. The other thing to note is where we've got an asterisk next to one of the event numbers, that denotes a rainfall event. Anything without an asterisk is an irrigation event. The other thing to note is the variation in irrigation runoff volumes. So this is basically an irrigation runoff event measured at 3 flumes. The 3 flumes were located just several rows apart on a uniform block, and yet the time that the water arrived at each of those flumes varied by 1 hour, and the height that the water got in, the height that the water was through the flumes also varied quite substantially between each of the flumes in this particular illustration. So that's just something to bear in mind. A lot of people who aren't familiar with furrow irrigated systems think that it's, you know, quite a uniform system, and that the volume of runoff will be quite uniform across the block, across the paddock, and it most certainly is not. This one here is a similar thing, except it was a rainfall event. And again, you know, with the irrigation runoff volumes, you can explain some of the variability there due to differing inflow rates, different pressures in the cups at the top of the paddock. But this is really just demonstrating that we also see that kind of variability in rainfall runoff. Same situation with the flumes, just a couple of rows apart, and yet the height that the water got through the flumes was quite different from one of those flumes compared to the other 2. Generally, the duration was fairly similar, as you would certainly hope in a rainfall event. But really, this just illustrates that, you know, perhaps there was more compaction in these 2 rather than this other one. So those are just some of the challenges that we face when we're taking measurements in a paddock. As Russ indicated, what we've found across this project, which was 8 individual sites across 2 years, so essentially 16 you know, separate data sets that we've got, is that the majority of nutrient and chemical losses typically occurred in those first 3 to 4 runoff events after application. So whether they be irrigations or rainfall, it was really that proximity to the application date that was important in terms of the losses. And for that reason, as Russ mentioned, it's important to carefully manage those first few irrigations in particular to reduce the majority of losses. So if we can carefully reduce the amount of runoff from those first few irrigations, we'll go a long way to reducing the pollutant loss from the paddocks. And rainfall events, as Russ and others have mentioned, you know, it is difficult to manage for rainfall events. They can be managed by maximising the coverage of fertiliser and careful timing of chemical applications. But of course, you know, unseasonal early rainfall events will yield higher losses than those rainfall events that might come later on in the wet season in January, February, March, which is when we get the majority of our rain. I'm just going to go through the 8 sites now. We don't have a lot of time. That's why I'm sort of rushing through it. We won't have a lot of time to drill into the in-depth sort of findings, but just generally, this is just one of our sites. It was a chemical application site. On the right-hand side, we've got last year's results, and then we've got this year's results. So we've got the 2 years side by side. What we're really interested in showing here is the difference between the 2 years. Last year, we had basically the full 8 irrigation events before we got rainfall. The highest concentration, we're just looking at concentrations for this pesticide trial, the highest concentration of losses of the 2 products that we were comparing occurred in those first couple of irrigations immediately after application. And then there was another kick up in the first couple of rainfall events later in the year. When you move to this year, similar pattern, except that we actually got a rainfall event early on in the season. So this was actually in late July. It was only a couple of weeks after application of that chemical, but it did drive quite high losses, as did the first irrigation. Then it dropped right off, and we got a little bit of a bump up in those first couple of rainfall events in January. So again, you know, the main trend we're really focusing on here, we don't have time to go into the individual chemicals that we were comparing so much, but essentially the trend was similar across the 2 years. And those main losses always occurred in those periods of time immediately after application. So, you know, no surprises there really. The second trial was a different site, but it was basically trialling the same 2 chemicals. And again, similar trend, we've got last year's data set here, this year's data set here. Last year, main losses occurred, first irrigation event after application, first couple of rainfall events. And exactly the same this year, in that the first irrigation event and the first rainfall event post-application certainly drove the highest concentrations at this particular site as well. If we move on to the next trial here, it was another pharmacist trial. What we were looking at with this trial was comparing the nitrogen levels, different forms of nitrogen. So we looked at total nitrogen, DIN, and dissolved organic nitrogen in a back-to-back soybean crop, all done in the 1 year, followed by a millet crop. Now, again, we're just looking at concentrations in milligrams per litre. What's interesting here with the back-to-back soybean crop was we had the first soybean crop is represented here. There was very little inorganic nitrogen applied with that crop. And as a result, your concentrations are really quite low and quite stable throughout that whole crop. Then that crop was harvested and it was cultivated and rebed formed in preparation for the next soy crop. And what is of interest here is the fact that following the disturbance of the previous soybean biomass, what was left over from the crop, it was cultivated and disturbed as part of that bed forming. We then had a pre-irrigation, a pre-water prior to the planting of the second soy crop. And immediately what you'll see is the grey is the organic nitrogen. You see a spike in the organic nitrogen as that soybean organic matter is worked into the moist soil. So you see much higher rates of organic. And then as that organic nitrogen declines, that's the grey, the DIN or the inorganic nitrogen starts to increase as that organic nitrogen is converted or nitrified or mineralised, as some people like to call it, into inorganic nitrogen. So again, with the second soybean crop, there was virtually no inorganic nitrogen applied, but you see that strong effect, and it actually occurred over 6 weeks because this was summer. Ordinarily, it might take 2 to 3 months for this to occur in the cooler weather and in drier conditions, but because it was summer, the high temperatures and the moist soil, that conversion happened really quite quickly. And over that 6-week period, then the DIN and the organic N started to decline, and it pretty much levelled out until the first couple of rainfall events later in the year. The soy crop was
Sorry, Alan, just there's another 5 minutes until we move on to
okay. Yep.
Thank you.
The soy crop was then followed by a millet crop with organic nitrogen applied, and you can see the high levels of organic nitrogen in that concentration. I'll just move on quickly because we're running out of time. This particular trial was looking at stool split versus side dress. This one, again, we had 2 years worth of data, but what we're just looking at here is this year's worth of data. We had similar trends over both years, but I've just presented the loads as well as the concentrations side by side. Again, demonstrating with the concentrations of nitrogen that the greatest losses occurred in those second and third irrigation after application, and then again in the rainfall event. What we see with interest here is that the side dress lost more in terms of concentrations early in the irrigations, but then later in the season when we had the rainfall events, the stool split actually lost more, likely due to stranded fertiliser in the hill getting flushed out by that rainfall through the hill. So that's that one. Here we move on to another site. This one we were looking at the effects of cultivation versus non-cultivation, as well as there were some rate differences in these applications. Again, what I've done here is I've put the concentrations on one side and the loads on the other side. This is just for this year, but again, we've got data over 2 years and they show the same trends. What is really interesting out of this one is that the non-cultivated generated much lower loads of nitrogen overall, particularly with the DIN, compared to the 2 cultivated treatments. And again, you see that the higher concentrations were in those first irrigation events after application. So this is sort of suggesting that the nitrogen rates were not as an important a driver of nitrogen loss as the cultivations were at this particular site, and that trend followed through over the 2 years. This site, we looked at manure versus just standard inorganic nitrogen application. Again, I've put concentrations on one side, loads on the other. What is interesting here is that the manure yielded higher losses than the standard practice, particularly obviously when it came to organic nitrogen, which is what we would expect. And we think that's mainly due to the fact that the manure was broadcast rather than incorporated. It was a broadcast application. But what is of interest to see is that the manure application, other than the first irrigation, it generally had a fairly sustained loss across the irrigations, unlike what we see for the inorganic nitrogen, where you normally have those losses greater in the first couple of irrigations. We had a little kick up in the first couple of rainfall events, and that's really quite normal as well. This particular trial here was looking at irrigation practices. So we looked at 3 different irrigation practices. We had past practice scheduling, which is just the usual, set it on an 18-hour or 12-hour set and go and turn it off. That was the green one. Then we had automation plus past practice. So basically it was getting turned off automatically when the water got through. And then we had automation plus IrrigWeb scheduling. So the IrrigWeb scheduling was telling you to water when the crop actually needed watering, when the soil moisture levels in the crop told you it needed to be watered. And what's interesting here, we've got the loads for both years side by side. It follows a similar trend in that the automation plus IrrigWeb scheduling yielded much lower losses of nitrogen compared to the other 2 treatments. And in particular year 2, which is this one here, you really see that quite noticeable. Year 1, we had a few teething issues with the technology, with the irrigation technology, which caused some over and underwatering episodes. Year 2, we tightened that right up, and you see quite strong results there. So really the IrrigWeb scheduling combined with the automation yielded much lower losses of nitrogen than the other 2. Nearly at the last slide, Renee. This particular trial here was looking at it was basically a nitrogen rate trial. It looked at 0 nitrogen as well as 3 different rates of nitrogen application. We've got the loads in kilograms per hectare for both years side by side. we had quite a few issues with the year 1, which we tightened up for year 2. So we're much more confident with the year 2 results. But having said that, the site had a lot of issues, which may have led to cross-contamination between the nitrogen rate treatments. They were only 3-row treatments, so we can't rule out that there wasn't cross-contamination between some of those treatments. Had very low hill profiles as well, which meant there was always the possibility of overtopping of the hills. So I guess the main take-home message out of this one, if we look at the DIN, which is the one we're most interested in, the 0 end rate yielded very low losses of DIN, as you would expect and you would certainly hope. The 3 nitrogen rate treatments yielded higher levels, as you would expect. The difference between them was, as I said, somewhat complicated by the fact that there's certainly the likelihood there was cross-contamination between the treatments. But what we're really focusing on is that 0 treatment, as you would expect. What was interesting was the high levels of organic N in the 0 treatment had sort of kicked in to take that place as well. So last slide, just to reiterate what Russ had said earlier, you know, what we're really finding out of this, and we're trying to get the message through that, you know, the thing that we really can control across all of these are those first few irrigations after fertiliser or chemical application. Rainfall events, we all know, are hard to control, but certainly if we can manage those first few irrigations after application, that's one of the keys. Improved irrigation practices include better scheduling. So the irrigation scheduling trial gave us a really good indication of what might be going on there, and how the IrrigWeb and the automation certainly looking very, very promising in terms of yielding much lower losses of nitrogen. And the tailwater capture through appropriately managed recycle pits. And I have to put the appropriately managed in there because, you know, if you're letting that water out one way or the other, then it's not appropriately managed. It really does need to be captured on that recycle pit and not discharged to the downstream environment. And what Russ was alluding to is currently we don't feel that these practices are adequately captured or recognised in the Paddock to Reef program. And we understand that it's, you know, it is probably quite difficult to do that, but it really does need to be recognised and captured as best as possible. So that's it for the presentation. Unless Russ had anything further to say, he's shaking his head.
Okay, excellent. Thank you, Alan, and thank you, Russ. Those are really interesting findings there. Now, I'm going to give everyone a heads up. We are looking like we're probably going to finish closer to 2:30 rather than 2:15. So that's just a heads up if people need to organise themselves. Now, I would like to invite maybe just one comment. I know that, I'm pushing it a bit here, but if we can just have sort of one comment. And I see that Adam's got in, and it's probably good to hear from you, Adam, given that, as Alan said, these practices aren't really reflected in P2R. So would you like to provide a comment on that?
Yeah, I guess my comment on it is, like, it's all pretty new stuff. So when we wrote the questions, you know, a few years ago, this wasn't really something we were looking at. But I also said, another thing I said before was, you know, our job is to you know, try and tell the story as best as we possibly can. So for these things here, it doesn't fit in our normal framework, but it's pretty clear that if we can reduce those first few irrigations, we'll do as much as we possibly can to get it in. Like, if people are doing these sorts of practices, we'll do what we can to try and represent that as an improvement. Like, that's no issue at all at getting it into Paddock to Reef. It's just that it's not, the current framework for reporting is not there. Yeah, but it's you know, pretty clear to me that it does have an impact, so we can do whatever we need to do to get it in.
Okay, Rob, I can see you've put a question there asking Alan to clarify. Does that answer your question as well? Rob, are you there?
Sorry, having difficulty unmuting. I guess what I was just trying to understand, Owen, is the statement that they're not adequately captured by the P2R survey. I mean, if you're adjusting your irrigation to reduce runoff, I would have thought it was captured by the questions. So can you shed some more light on that, please?
Yeah, I guess what we were really coming at is overall, we don't believe that the interaction of irrigation management at that level necessarily has been addressed to this point in time. So as Adam said, I think there's constant improvements being made and attempts being made to capture that. But I guess as a whole, our growers are just saying to us, well, in the paddock to reef survey questions that we are asked, there's not enough detail for us to elaborate on those attempts that they're making on the ground to adequately manage those first few irrigations in particular to avoid those early losses.
Now, I can see there are a number of comments here in the chat. Mark, you've got a comment here, but I think after Mark makes his comment, we will have to go to Belinda's session, just so Belinda has adequate time to present as well. So Mark, do you need to make any further elaboration on your comment here? You said that several of the practices, like the timing of early runoff and rate, are modelled.
Yeah, I think, and that might be a different question as to whether they're in the management adoption survey. I'm pretty sure, well, I know we model N rate, and it's good. That was a really good talk and a really good set of data too. I'm just going to check whether we model some sort of delayed or like either early application of the chemicals or a delay in irrigation, because there's obviously a strong story there, which we actually knew about from other monitoring in the Burdekin from years ago and up north. So anyway, it's good set of data.
All right, thank you. And can I encourage everyone, obviously Arlen and Russ are local, so they're not far away. So can I encourage anyone, if they do want to discuss these further, and certainly our Brisbane friends, if you do want to discuss this stuff further with Arlen and Russ, absolutely get in contact and have that discussion. That'd be really good. Okay, Belinda, you are here somewhere among my Brady Bunch layout. Okay, I've found you. Belinda, are you there? Are you ready to present?
Yeah, I'm here. I'm here. Thanks everyone for having me today. As a lot of you will know, I'm actually based up in Gordonvale, and the work for Cane to Creek in the Vatican has been led very well by Gracie White with support from Anthony Curo, Jai and Jesse from SRA, but it's also a collaboration, and just like to say thank you to BPS and BIFMAC for all the work that they've been doing with us to make this work. And since I haven't been there on the ground, I'm not going to step you through all our different trials and things because I don't think I'll do them justice, but I've picked a few out, so hopefully it's informative. Now, here we go. So for those who are not aware, Cane to Creek is a project funded by the Great Barrier Reef Foundation, led by SRA. And we have little satellites going from Mossman all the way down to the Horton. So most of my time's been taken up between Mossman and the Tully and a bit of the Herbert. But so the objective of the program is to connect what happens in the paddock to what happens in the creek. And we're looking at really promoting practice change where there has already been a reasonable amount of research done. So we feel confident that it's something that growers can do without losing productivity, and it should be economically viable, and it should result in a water quality improvement. And we work locally with growers and industry to try and make whatever is demonstrated relevant to the local area. So, oh, and I should note that we started out as a tiny little project up in the Mulgrave with funding from the Office of the Great Barrier Reef. And it has grown and is now in Mackay and Infinity and beyond. So Cane to Creek in the Burdekin, as I said, it's a partnership between BPS, BIFMAC, SRA, and we've been running around 6 trials a year, and like the BRIA project, which obviously we try and collaborate and make sure our messaging is the same and have a lot of the same practices in the field so that we're not stepping on each other's toes or contradicting each other. So we've got water quality, productivity, and when we're looking at weeds, we also look at efficacy. And a lot of our projects, as you'll see, or trials have been replicated over the 2 years or repeated over the 2 years. And that one doesn't work. So in the first year, we have a comparison of metribuzin and atrazine, which I'll step you through in a bit more detail. And we've also looked at delaying irrigation. So like Arwen has just highlighted those first 4 irrigations or the early runoff, much like in a rain system. That's where we have most of our losses. So looking at what can we do by delaying irrigation. We looked at accounting for mealmud nutrients and placement of fertilizer, which I think we had a different result, must have been a different soil type. And also just looking at what's coming off legumes, which Arwen showed quite well. In the following year, we repeated the delay of irrigation and the accounting for mealmud nutrients and the placement trial, and we went into the plant cane for the accounting for legume nitrogen, and that will be harvested this year through BPS. So the key points from year 1, where we've got some of that data back, or we have all of the data back. The placement trial found the side dresser had the best productivity and best water quality outcomes. And the irrigation water came through a lot more evenly where the mealmud was banded than when it was broadcast, which seems logical. The irrigation timing, there was a reduction in herbicide loss, but as I'll show you a bit later, it's not totally straightforward. The herbicide demonstration with the atrazine and the metribuzin had, like the results were as we would expect, and I'll walk you through that. So this is the metribuzin and atrazine demonstration as promised. So the first thing you'll notice is the 2 different treatments. We've got 1/2 kilo of metribuzin, which for those who don't know is mentor or soccer. And there's 2.5 kilos of atrazine. Both of these, both treatments have a Mazapic at 300 mils, which is flame or spark. And you can see I've done just a little economic analysis there. For those of you who are in the know, these are wet tropics prices of those chemicals, but I can't see them changing much on the coast. The metribuzin comes in at $22 a hectare and the atrazine comes in at $22.25. Mazapic is very cheap as well. And I guess what you'll see there is metribuzin is quite an expensive herbicide. So reducing the rate makes it more affordable, but obviously it has to be effective as well. So thank you to BIFMAC for doing the water quality work. And I've just got a couple of snapshots from your old grower handout here, Arwen. So we've got, hopefully you can see my mouse where it says atrazine, and you've got a very tall orange column and a shorter blue column. That's 1 flume that was on the treatment where atrazine was applied. And the next one, sorry, I'm wrong. The orange column is what's come through the flume where the atrazine was applied, and the blue columns are what has come through the flume where the metribuzin was applied. So the first thing you'll notice is we've got a lot more atrazine coming off both of these 2 columns under the little atrazine header are atrazine losses. And all the work that I've done over the last 5 or 6 years on herbicides show that there's a direct correlation between the rate of herbicide applied and the amount of herbicide that runs off. There's a couple of exceptions, being pendimethalin, which is stomp, or flumioxazin, which is Valor. to a lesser extent. You would expect similar with Treflan or but atrazine always runs off a lot because we use a lot, and it's also very mobile. When we move over to the metribuzin one, you can see obviously there's 500 grams only applied, so there's a lot less loss. The interesting thing here is that there was a bit of diron moving through, even though it wasn't applied. And if you come across to these other graphs, we've got the atrazine flume up the top, the metribuzin flume below. You can see that those first 4 irrigations were very important. That's where majority of the losses occurred. There's a little bit of a spike at the first rainfall event on the metribuzin, and a similar but much smaller one on the atrazine. So I guess that reinforces, just imagine if you can catch those first 3 or 4 events in a sediment trap and recycle them or apply a flocculant and encourage the breakdown of that chemical, your loss to the environment would be almost negligible. Also just note the imazapic that was applied to both treatments, 300 mils, which is equivalent to, I think, around 150 grams of active ingredient was applied. So there's a lot less chemical to move off in the first place, even though it's quite a soluble and mobile herbicide. So you can see again the imazapic, even though it was quite different on the different treatments, the pattern is the same with more losses early and that bit of a spike with the rainfall. The diron that was reported in that first graph comes with the rain, and so I guess that could be a bit of contamination, perhaps from another paddock, or it could be more some older chemical that was applied with some, you know, being brought into solution from the soil. Perhaps it was below the surface or something like that. But you can still see there's a bit coming through the irrigation water. And even up here in the wet tropics where we get a hell of a lot of rain, whenever we soil sample or trash sample or check water that we're going to use in a rainfall simulator, it's pretty unusual to not find traces of diron. It's around. And I just thought I'd note here that the imazapic is a photostable herbicide, so that got a much longer half-life than the metribuzin or the atrazine, and it'll be there for a lot longer, which is good for weed control. Perhaps, I don't think it's too much of a problem for water quality because it's applied at such low rates. Now, I don't have all of our efficacy data, but certainly when we're presenting to growers, we make sure we've got a pretty comprehensive set of efficacy results, because you're not going to make a change based on water quality alone. So this looks like a big difference. The metribuzin had a 3% area covered with the weed, where we do our weed monitoring plots, and the atrazine was 0.5. I don't really think that's huge, and certainly my experience with growers, if they knew that there was such a big difference in loss and the cost was virtually the same, it's something they would definitely consider. I think that you're going to go back and do another spray anyway for your vine control, and maybe you might bring that forward a little earlier, or maybe that 3% cover, that's not exactly your block being taken over. So I think that was quite a good trial. It's a shame we didn't get to continue it, but I believe there was an itchgrass problem in the block. So I'll move on to, this is the only other one I'm going to go through with you. So this is delaying irrigation to reduce loss, which I guess when it comes to practices seems to be the topic of the day. And I think that the results weren't entirely expected. So the blue line on our graphs is a delay of 2 days. The orange line is a delay of 4, and the green is a delay of 6. And so the first chart you'll see is 2,4-D, and As you'll know, 2,4-D is a knockdown herbicide. It's got a half-life of 4.4 days. It's a chemical that's designed to be sprayed onto weeds, kill the weeds, and then we don't need it anymore. We don't need it to hang around. And so you can see that a lot more was moving at 2 days than at 4 and 6. And that's exactly what we would expect. Then when we come to the metribuzin, it's a little bit more of a complicated story. And you'll see down here, metribuzin has a half-life of 19 days. And so while obviously there's herbicide being moved in the water in our 2,4-D situation, you've also just got the herbicide breaking down in the environment. So we've got, I've actually just copied Arwen and Mackenzie's notes here. They were unexpected in that the 6-day irrigation treatment yielded the highest concentrations in runoff water. The 2 and 4 day results were actually quite similar. So I guess that could be something about paddock variability, in that if we've got more water moving through a flume, we tend to have more of everything moving. But I guess it shows that science isn't easy. And when we're just trying to demonstrate it, what we think we know, we don't always know what we think we know. So the third one is isoxaflutol balance that was applied. And so balance is another one of these photostable products, and it has a half-life of 61 days. And here in the tropics, you'll see someone might have put some out in September, and then you'll see the grass on their headlands turn white in January. It's pretty effective on grasses, and it definitely does hang around. So you can see we had the highest losses in the 4-day, but the 6-day seemed to be enough to perhaps, I guess what I can say is I've got the solubility here as well. So metribuzin is a lot more soluble than the isoxaflutol. So having those extra days may have been what it required to just get a little bit better binding to the soil. So even though it's not perfect result, it still supports that theory that delaying irrigation is a good thing to do, and managing those first events can solve a few problems.
Belinda, we've got about 5 minutes left.
Okey-doke, I'll whiz through these. This is just what we've learned, and it's really not about what we've learned in terms of practices, but what we've learned in terms of running these kind of projects. So up here as well, we've often had 1 flume per treatment, even though we'll have 4 replicates. And sometimes we just get confusing results. So you really can't have enough replication. And that means I believe that I would have preferred to have 1 site per region that's really well instrumented and done to the T. In terms of productivity, we've always had the replication there, and we've pretty much every harvest or every time we've gone out to monitor weeds been happy that we've done that, because there's so much variability, and it's not just about soil. It's pigs and bugs and logs that come through and crash your cane down, and high spots and low spots, and sand that's been moved. It's everything. And the other thing is replicate the way that you generate the information. So across the project and often across regions, we've got our creek sampling, we've got real-time sensors, we've got rainfall simulation, and we've got the flumes, as well as efficacy monitoring and harvest data. And that has meant, even though things might go wrong, we've always got some good stuff to share that can help growers make decisions. And I guess the other stuff is just get the information out to the growers. Every grower I meet knows of work that's been done in their region and even on their farm where they haven't got feedback on what's being done, and it leaves a real bitter taste. So be generous with your time and the information respond to requests for more information and more detail, have something for your tight little group, and then have something for the wider group, because otherwise you can end up with rumours and gossip and things that you've got to deal with. Have clear messages, go with the energy and build on what you started. And Gracie, who really led this work, has also just put a few words together, and she helped me with this presentation too. So she really got a lot out of interacting with growers on a day-to-day basis, responding to their questions, getting them more information, and using those, I guess, the paddock demonstrations are a way to build relationships and help people with a whole lot more than what you might be focusing on. So that's it for me.
That's great. Thank you, Belinda. There's some really good good lessons there, and kind of ties in with what we've heard earlier about, you know, being asked what you do on the farm and actually, you know, being asked the right questions. So thank you. Now, do we have sort of one or two comments for Belinda? I know there's been a couple of comments come through the chat, but we have time for one or two questions for Belinda about this project.
They've gone.
Yeah, they've either gone to sleep or you've just done the best job ever and you've covered all your bases.
Sent them to sleep.
Yeah.
Good one.
Yeah, no, look, it's all good. Well, again, you're likely based too. So, look, thank you to you, Belinda, and also to Arwen and Russ for those presentations, because I know the organisers of this forum were very keen to have some representation from those local on-ground projects. So, thank you all for that. Okay, so some interesting feedback coming through here, and you can see some common themes emerging here too. Making sure that it's sort of regionally specific. There's a couple of comments there, maybe some clarification about data, such as the age of it, where it comes from, having all current practices included, better understanding of sort of the back end of that data, maybe how certain things are calculated, weightings, etc., how the targets and things come to pass. Maybe some bit more understanding about, yeah, again, the back end, the modelling, that kind of thing, better access to data. And having targets that are realistic and achievable, absolutely. I don't think anyone would disagree with that. And landholder representation. Sure, so you can really see some common themes coming through in those questions about regional specificity, I can never say that word, understanding sort of the back end of those things, you know, maybe communication and landholder representation. You can see all those things coming through here. So this is really good feedback. Thanks everyone. This is actually going to be saved, and certainly happy to circulate these public shared feedback to you all afterwards if people are interested in receiving a copy. Yeah, that's definitely very helpful for us as Paddock to Reef forum organisers, and also for the crew who actually work on the back end of the program. So that's good. No, thank you for your honesty. It's good. All right, I'm going to move forward now to sort of our last slide here, which is really any other comments. So if you've got any sort of feedback, suggestions, anything like that you'd like to add, now's the time to do it. And Rob's also just put a reminder in the chat. He just wanted to remind you all that our original agenda before Zoom actually had a lot more local presentations, but we actually thought folks might be a little zoomed out. So that's the number of local presentations was reduced then. So, but it's certainly good feedback going forward, all of this. So we've got a few action items coming out of today. So there's been some really helpful papers mentioned, some helpful links put in the chat, some undertakings to follow up with relevant materials. So we'll make sure that happens and that you will receive copies of those. There's been some talk about possible deep dive workshops for those catchment loads monitoring and just for the modelling in general. So we can certainly, if there's sort of interest in attending that and also funding to run those, we can certainly look at putting those together. So again, we'll be circulating an email afterwards with all of these sorts of follow-up actions. So we've got a couple of comments coming through here. So useful to see the details, infuse some more positivity in future forums. I like that one. Well done to the organisers and presenters, absolutely. And the format works well, okay. No, that's great. Look, keep those comments coming, folks. I will leave the slide up here. But does anyone have any final questions or comments before we formally close for today?
I do.
Okay.
It's
Hi,
Phil
Phil.
Morano. You know
G'day.
that I don't mind speaking my mind. You should know that about me by now.
Absolutely. All good.
I think it's important that everyone working on paddock to reef and anything to do with the reef really needs to understand what some of their outcomes and some of the decisions that their outcomes drive. We hear a lot about the value of the reef and how valuable it is to all Australians, and I understand that. We live here, we've lived here all our lives. We understand the importance of the reef. But we don't hear much about the value of us, people in agriculture. We seem to be missing whenever they talk about value. A lot of the changes that are being forced on us because of, or forced is the wrong word, a lot of the changes that are being asked of us to do to help protect the reef, you've got to realise the cost that pushes onto growers. And you've got to also realise how soul destroying it is for growers when we constantly hear that we are about to destroy the reef. And I think people need to keep that in mind with what they're doing. And we need to be sure that the science that's being used is top notch. The modelling that's being done is top notch, and the information going into that modelling is unquestionable. And that's really important, because this really does have real life implications for a lot of people. That's all I wanted to say.
No, thank you, Phil. That's a really, really important message and a really positive collaborative message. So thank you for keeping in the spirit of what we're doing here today. That's great. Thanks for your contributions. Okay, and Michael, looks like you have something you'd like to add.
Oh, I'd just like to say, Renee, thank you very much for facilitating this. I thought you did an extremely professional job in keeping everyone under control and being patient. And yeah, no, thank you very much. It's one of the best facilitated Zoom sessions I've had. Thank you.
Wow, thank you, Michael. You can come to my sessions any day. That's good. But thank you so much. Yeah, really appreciate the feedback. Thank you. I'm glad it was helpful to everyone. Excellent. All right, well, if there's no further comments, folks, thank you once again for your time and your attention and your energy during a very long day sitting on the computer. Safe travels home, and we look forward to sending you that follow-up information we've talked about. Thanks, everyone. Take care.